Hey guys, welcome to my new series on Retrieval Augmented Generation with Langchain. Now, you may have heard of Retrieval Augmented Generation or RAG before, since large language models are becoming more popular. Basically, it allows a large language model to have a knowledge base. Let's talk about what it is. So, first of all, why do we need RAG? So, whenever you ask ChatGPT a question, it may or may not know the answer to your question. So, for example, at the time of recording, if you were to go on ChatGPT right now and ask the question, "Who won the 2024 US election?" it wouldn't know the answer unless you have the search mode turned on. This is because ChatGPT is only trained up to a certain point, and it depends on what model you're using as well. So, because, for example, ChatGPT doesn't know anything beyond October 2023, if you ask it any current events, it obviously cannot give you an answer beyond that, right? Now, sometimes though, when you ask a question that it does not know, it will still give you an answer and it will say it confidently as if it knows that's the answer for sure. That's called hallucination. You may have heard of that. So, RAG is one way that we could solve this. This is providing context to ChatGPT or any large language model so that it can accurately answer questions. So, another good example is if you're trying to have an application that can answer questions about your company's handbook, specifically something for your company. Obviously, ChatGPT doesn't know anything about that. So, what you could do is every time you ask a question to a large language model, you also give it the context it needs to answer the question. So, in this case, the original prompt question along with the handbook, and it will use that together to answer the question accurately. That is the basic idea behind RAG, Retrieval Augmented Generation. So you ask a question, it retrieves relevant information, it combines that relevant information with the original question, and then ChatGPT will use all of that combined to give you an answer. Okay. So back to the previous example, if we want to ask it a question about current events like who won the 2024 US election, you could have it so that when you ask the question, it will also look up the latest information on Wikipedia of the 2024 US election to provide that along with the original question, and then it should give you an accurate answer, which is Trump. So, long story short, instead of hoping ChatGPT will have the correct answer, give it the information it needs to give an informed answer. And at the same time, since you're providing it the information it needs to give you a correct answer, you'll be confident that it should be giving you a correct answer instead of hoping that it doesn't hallucinate. All right. So let's go into a little bit more detail on what RAG is. So retrieval augmented generation breaks down into three different phases: retrieval, augmented, and then generation, right? Retrieval is the first step. So you're going to ask a question, and then we're going to have a retriever, which the whole job of the retriever is to look up relevant documents. So in the example of your company's handbook, if you ask, something about maternity leave, the retriever will go into your company's handbook and look up any relevant pages that have to do with maternity leave. And that's it. That's retrieval. It's retrieving relevant documents based on the query that you give it. So for the election example, you could have a Wikipedia retriever that looks up the 2024 US election Wikipedia page, and that will be the context provided to the large language model. So once you have your context, which is our relevant documents or just relevant text that we can provide, we do augmentation, which is combining the original query or question along with that retrieved context or documents. We combine it together. That's augmentation. And then we send that to the third phase, which is generation. So we're sending that full prompt with the original question and the relevant documents to a large language model, and then it generates a response. That is it. Instead of just asking ChatGPT a question, you ask it a question, it gets relevant information, it combines that all together, sends it to ChatGPT or a large language model, and gets an informed answer for you. So RAG breaks down into two different pipelines that we're going to go into a lot more detail when we actually start coding and stuff like that. So first you have the indexing pipeline, and then you have the generation pipeline. So indexing is all about ingesting and processing all the relevant documents that you'll be using to answer questions. And then generation is all about what I just described on this page, which is taking a query, getting relevant documents, providing them with the query to give an informed answer. That's it. So that's just a high level overview. Like I said, we'll go into more detail in the future, okay? So what do you need to know to be successful in this series? First of all, you need to know the Python basics, so just how to work with Python in general. You don't have to be an expert or anything like that. It's also helpful if you have an understanding of what Python notebooks are, but you don't really have to be an expert in that as well. Also, what's really important is you should understand what a large language model is. I'm assuming if you clicked on this video, you know what it is. So you should know what ChatGPT is. You should know basically how it works. You ask it questions, it gives you responses. You should have an understanding of maybe what tokens are. Tokens are the unit of information that large language models use. But besides that, you shouldn't really need to know about much else, okay? After watching the series, what can you say you know how to do? So first of all, it's going to be that indexing pipeline I told you about. So that'll be loading documents, splitting documents, which is chunking documents. I'll be going into detail on what embeddings are, which is actually big in natural language processing and machine learning. So you learn how to take text and encode it as numerical vectors, which we can then store in a vector store to retrieve later. So you'll learn all about that. That's all about storing documents. Then you'll be learning about the generation pipeline, which I also described, which is the act of retrieval, so retrieving relevant documents, how to use chat models, and then how to use prompt templates. Finally, we're going to end the series with 2 examples of actual applications that use RAG. So first, we're going to make a Streamlit application. Streamlit is just a library that you can use in Python to make websites really easily. It's really popular for machine learning. But basically, we're going to make a website that allows you to input a URL. We're going to ingest that URL, so download all the information from it, and then you can ask questions about the website, and it will give you informed answers using RAG. And then we're going to build upon that with a more advanced example that will allow you to upload files, so text files, PDFs, and stuff like that, and ask questions about the PDFs and give you actual answers. So everything that I've talked about will be done using Langchain, which is a very popular library and framework for building large language model applications. Specifically, it's very popular with RAG. So a lot of the time when you hear about RAG or Retrieval Augmented Generation, you'll hear about Langchain as well. So this will allow us to do everything that we need to do, including all these steps here and these pipelines and everything that I just described to you. So I really hope you guys are excited to get started in this series. Everything that you're going to be learning is really relevant to today because RAG is very, very popular. So once you learn this, you'll be able to put this on your resume and say, I know how to do RAG with Langchain. I want to show you guys real quick the repository for this series, which has all the code for all the episodes, and I'll have a link for it in the description below. So here you can find the table of contents for every single episode's code. So if you want to watch the first video on the environmental variable setup, you just click this, and here's all the code for it in a Python notebook that you can either download or just copy or whatever you want to do with it. Or you can just also clone the entire repository if you want to. So every time you watch a part of the series, then make sure you check the description for the GitHub link, come here, and then find the code for the episode that you just watched. So if you're excited and ready to learn about Retrieval Augmented Generation with large language models, then keep watching. Alright, I'm going to start by showing you guys how to set up a basic Python environment so that we can get started with our Jupyter notebooks and just get started coding in general. I'll be using VS Code for this, but you can use other IDEs if you want to, like JetBrains PyCharm or something else, okay? But I think VS Code is probably the most popular one, so that's what I'll be using. So the first thing that you want to do is just open up VS Code in a folder that's going to represent your project. And then what you want to do is open up a terminal, so terminal, new terminal. And first of all, before you do anything, also make sure you have Python installed. You can get your Python version by just running python-v. I don't know why it spams all that, but I have Python 3.11. That is the version that people recommend at a minimum, Python 3.11. But if you have the newest version, that should also be fine. Should is the keyword here, but at least have Python 3.11, okay? So let me exit out of this. Now, once you've verified you have Python installed, you can now create a local Python environment by doing python-m venv, which stands for virtual environment. And then now you want to give the virtual environment a name, but people just usually leave it as venv, virtual environment. So this will create a new local virtual environment, which includes a local version of Python. And this will also make sure that all the packages that you install are just local to this project folder, not global to your whole computer. So you can have different projects with different dependencies and versions, stuff like that, okay? So very important. Now that you have a Python environment, it's very important that you do not install new packages until you activate the environment. This is something that you'll need to do every time you open the project or restart your computer or anything like that. Make sure you have the environment activated. This is going to be different between Windows and Mac. For Mac, you can do source venv /bin/activate and just make sure you're in the same directory as that environment folder you just created. If you're on Windows though, you could do venv/scripts/activate. Press enter and there we go. So the way that you will know that your Python environment is activated is if it says this. If it has the, in parentheses, the name of the environment when you're in the terminal. So that's how you know it's good to go. So if you want to now, you're good to install packages. So we can do pip install Langchain. Now it's installing the Langchain package only to this environment. Like I said before, not global to your PC. All of the steps that I just showed you will be in a README in our GitHub. So just make sure to reference that if you want to remember all the commands and stuff like that, okay? Something that you'll commonly do is save your installed packages or your dependencies to a requirements file so that if you recreate your environment, it can automatically install all the dependencies that you had before. That way you can make sure your program is runnable on any machine, because it has the same packages and the same versions. So what you can do usually is after you install a new package or something like that, you can do pip freeze. Then you could do this angle bracket, I think that's what that's called. And then you do requirements.txt. So what that will do is take all the packages you've installed in this local Python environment and save them in the version numbers to the requirements file. So if we look at it now, here's all the packages. So now if you find yourself creating this environment for the first time, but the project already has a requirements.txt, you can install all the packages automatically by doing pip install -r requirements.txt. So that will do that. So that's it for creating a local Python environment. Now what I'll do is show you guys how to set up and run a Jupyter notebook, which is what we're going to be using to run our code. First, make sure that you have the Jupyter notebook extension. I don't know if it automatically comes with VS Code, but either way, just go to extensions and just search Jupyter. It's going to be this first one here. It's by Microsoft. It has an extension pack, so just make sure all of these are installed. It should maybe also come with your VS Code already, so just make sure you have this and you're good to go, okay? Now, once you have that, you can create a new Jupyter notebook in your project by creating a new file. We'll just say hello world dot, and then the extension is going to be IPyNB, so Python notebook, like that. And now since you have the extension, it's automatically recognized as a notebook, so you can create new code cells, markdown cells, stuff like that. So markdown cells are for documentation and text, code cells are for code. So markdown is like hello world, yo 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 yo. Once you have the text specified in the markdown cell, you can then confirm it, and now it shows it as markdown, which is cool. And then now if you want code, we can do some code. We'll just run hello world, like that. It's not showing any syntax highlighting, and it's not able to run it because you first need to select a kernel. So click select kernel. And then what you want to do is you can choose an existing Jupyter server if you have that set up, or you can just select your Python environment that you just created. So it should just be the top option, or just look at the file path and you can see that it's the local file, venv. Click that, and then now, there we go. It recognizes your Python, and you can also run it. It will ask you, though, to install the ipykernel package, which just allows you to run these Python notebooks in your local environment. So install that. It's going to do all that automatically, which is great, and then it should run it afterwards. There we go. It ran it. Hello world. Took 0 seconds. So that's how you can create Jupyter notebooks and set them up with a kernel and then run it. So now that we selected our local Python environment as the kernel for this notebook here, it will automatically inherit all those installed packages. And so any packages that you install either in the terminal or within the notebook itself will be shared within any other notebooks you create and use that kernel with. All right. So hopefully that all makes sense. That's pretty much all I'm going to show you for this episode. So now you guys know how to set up a local Python environment and then also set up notebooks. So thanks for watching, everybody. I'll see you guys later. Peace. Okay guys, so in these videos that I'm doing on RAG, I'm going to be using the OpenAI models a lot for both embeddings and also the chat models like GPT-4o. So for that, we're going to need an OpenAI API key. So I'll be showing you just real quick how to actually get one. So first of all, go to platform.openai.com and then go to log in or sign up. You can use Google account if you want to. After that, you can go to settings and then go to API keys. Then here you can create a new key. First, you might have to verify your phone number. So if it asks you to do that, then just do that. And then you can click create a new secret key. If you want to, you can give the key a name. So if you have different keys for different projects or different machines, you'll know which one is which in case you need to delete one. So we could say rag test, or how about rag series for the series. In terms of permissions, if you want to, you could restrict it to do only certain things because maybe you give this key to someone else and you don't want them to be able to spend money on certain things maybe or use different things. So this is just a way to restrict access if you want to, but I'm gonna leave it on all and then click create secret key. And then now what you want to do is copy this key that it gives you. It's this long string, copy it and save it to a file somewhere safe. I'll be showing you in the next part how you can actually save this to a .environment file so that you can load it into your project. But for now, just keep it somewhere safe and do not share with anybody else because if they have the key, they can spend money on your account. Make sure you copy it now before closing because once you close it, you cannot reopen it. You'll have to create a new key to see it again, okay? So click done once you have it saved somewhere. Once you have a key to actually use a model, you need to make sure that you have your billing set up. So go to billing and then make sure that you have credit available. So I have only $1, so that's okay. Models are very cheap. So just make sure you have a credit card added and then you add some credits to your account and you should be good to go. Sometimes you'll set up a key and use it and then it doesn't work. That's probably because you have no credits to actually spend. So that's it. Make sure you do that and you're good to go. Thanks for watching, everybody. Peace. Now I'm going to show you guys how to set up the environmental variables for a project. This is very important because if we use something like ChatGPT, we need to make sure that I can grab our API key because it needs to be able to communicate to OpenAI with your key. There's actually a couple of different ways you can do this. If you want to, you can create global environmental variables on Mac and Windows. For example, on Windows, you can go to edit the system environmental variables. You can add it there. But another easy way to do it for any system would be to create a local .env file, so .env. So yeah, the name is literally just .env. That's the extension. There's no file name, and it starts with a dot because it's a hidden file. And so inside of here, you just simply put the keys that you want to store. So in this case, we want to do OpenAI API key. If you're planning on using OpenAI, it needs to be this exact name here because it doesn't recognize any other name. So that's the name it will be looking for. So once you have that, put an equal sign, and then after that you put the key. No spaces or anything, just put the key that I taught you how to grab before, okay? So paste it there and save the file and you're good to go. After that, I'll show you guys how to make sure the key is loaded in so that Langchain can grab it. So we'll do new file. We'll say environmental variables dot ipynb, so making a new notebook called environmental variables. So we're going to make a new code block here. Now what we want to do is make sure that the API key is able to be grabbed before we start doing anything with Langchain with OpenAI. So we could do that by doing, for example, API key is equal to OS, and we'll import OS dot environ dot get, and then you can now grab a environmental variable by name, so OpenAI API key. And so now this will contain the key. Obviously, if it can grab it, if it cannot, it will be, nothing. So we can do if not API key. If that's the case, we're just going to throw an exception, say OpenAI API key is not set in the environmental variables. It's a very good idea to run code like this at the beginning of your notebook before you start working with anything, just to make sure that you have the necessary keys to communicate with their APIs, okay? The issue with this is that it's only if you have a global environmental variable, or at least an environmental variable that's not part of a .env file. So to make it load environmental variables from .env files, you can install a package. So we're going to do terminal, new terminal. We need to make sure to activate our local Python environment as I taught you before. So we'll do a virtual environment, scripts, activate. So now it's activated. So now we can do pip install, and we want to install python-.env. So that will install the package to our local environment, which we can now use above. Now we just need to import a function. So from .env import load environment. So now before we do anything up here, like grabbing the key, we can then call load.env. So this will, as the name implies, load your environmental variables from your local .env file, which should just be at the root of your project. So if I run this, there were no errors. So that means it was able to grab a key from our local file. So if we want to, we can just print it out. So we could say else print API key, and then let's run it. Look at that. There's the key. Obviously, you would have an actual key there, but you get the point. So as you can see, a local environment file is very useful for setting up your keys just in your project directly so that you don't have to worry about setting up globally or anything like that or running commands. One thing that's very important, though, is do not commit this to your Git. This is not something that you should include into your repository. So if you have a .gitignore file, specify this in that file because you do not want to obviously expose your keys to anyone else on the interwebs. So that's very important, okay? One other thing real quick is that if you change the contents of the .env file, like changing a key value, make sure that you restart your kernel because it won't re-grab it. As you can see, it's still the original one, so click restart, restart it, and let's try it again. There we go, it has the new value now. So yeah, like I said before, make sure you have this code at the beginning of your notebooks. It's a good idea just to make sure that's able to load everything that you need, like your API keys. So hopefully this video was helpful. So in the next episode, we can finally get started with our very first Langchain code. Alright, let's talk about how we can use chat models with Langchain. First things first, we usually want to check the documentation because this usually gives you the information that you need to know how to use this because it depends on what provider you're using, like OpenAI or Anthropic or any of the other countless ones that it has. So this will tell you specifically which packages to install and also how to use them. In this video, I'm going to show you guys how to use OpenAI just because that's pretty popular, of course, because it's ChatGPT. But the cool thing about Langchain is once you know how to do it for one, it pretty much applies to the others as well because chat models are an abstraction that applies to any provider that you have. So for example, if I wanted to do OpenAI, it already tells you by default what to do, how to do it. But you can select any other one if you want to, like Mistral, and then you also have a full list here as well, okay? But yeah, the point of this is to tell you that the documentation is your best friend. At times it's a little confusing or maybe outdated, it seems like, but it's very helpful, okay? I'll show you guys in a future episode how to use something other than OpenAI, like, for example, a Llama model instead, okay? So if you don't want to pay money and all that, that's perfectly understandable. You can use other options as well. All right, so let's get started. The first thing that we want to do is that as the documentation says, we want to install the Langchain OpenAI package. So within a notebook, you can either run this command just in your terminal, and that will apply to the environment you've selected, like here. Or if you want to run it directly in the notebook, you can just prepend this with a %sign and now run it, and it will automatically install the package. The Q flag makes it quiet, so it doesn't really output a bunch of stuff as it's installing it, so it's less spammy. Let's also just make sure that we have Langchain. So Langchain, it'll install both for us. So since we're using an OpenAI model, we want to make sure that we have the environmental variable set up. So I'll copy this from last time and I'll paste it here. This will just double check that it is set up, and it is, no errors, that's good. So now we can start using it. So now let's do from Langchain, we'll do OpenAI, import chat OpenAI, like that. Now we can instantiate a new model by doing model is equal to chat OpenAI. And we just want to tell it, there's a bunch of settings that you can provide, but at the very least, you want to provide it the model that you want to target. So we want to do model. And now you just want to give it the name of a model that OpenAI provides to you. So we could do, for example, GPT-40. And so now whenever you talk to this, model here, it'll be using that model version. So now we have a model that uses GPT-40. But of course, if you want a full list, you can come here on OpenAI, and it gives you a full list of all the different types of models that they have, such as 4.0, 4.0 mini, even text-to-speech models, all kinds of models, right? So we can click into 4.0, for example. We can see that there's a bunch of different 4.0 versions as well if you want to target a specific version. But if you just do GPT 4.0, this will give you this specific version here. In terms of which model you want to choose, it really depends on a few things like how much money you have, because certain models are going to be more expensive because they are better. Like the new O1 models are going to be high quality, so these are going to obviously be more expensive. Let's take a look at the pricing. So model pricing. So we can see for GPT 4.0, the input is $2.5, but don't forget that's price per 1 million tokens. So that's a lot, okay? So whenever you're using this, like we're about to use it, we're just sending simple prompts and getting a response back. It's not going to cost almost anything. It's going to be like 0.1 cents or probably less than that. So don't worry about that. But yeah, as you can see, O1, which is their newest model that they have available at the time of recording here, is $15 per 1 million. So much more expensive, but this is a very powerful model that can give you a lot of good capability. And then you also have audio models, $40. That's crazy. So yeah, that's the pricing. It looks like the cheapest one at the time of recording would be GPT-40 mini. So go with that one if you want to. It's only 15 cents per 1 million, which is really, really good. It's also a very fast model. It's our fast, affordable, small model for focused tasks. So it's not going to be as high quality as 4.0, but it's going to be faster and cheaper. So it's a trade-off with everything. So anyways, just go through this table here, select a model that you want to go with, and then you can instantiate the model on Langchain and just provide the model name. If we want to do mini, we can do mini. Now to talk to the model, all you got to do is do model.invoke. So we could say like, hello, and let's see what happens. Look at that, we got a response back. It says AI message, that's the type. And then within that, you have a content field. So hello, how can I assist you today? That's what the AI said back to you. And then you have additional, information like the amount of tokens that it took, completion tokens. That's basically the output tokens amount, the prompt tokens, how much the prompt was, total tokens. So that other information is there for you. But if you just want the output text, all you got to do is just do .content, and there you go. So let's redo it. There we go. Hello, how can I assist you today? As you can see, it's really, really easy to get started with Langchain. Now, of course, you could just import the OpenAI Python library that they have. They provide their own library that's constantly updated with the newest features. The benefit of using Langchain directly is that it's an abstraction, meaning that you can easily switch between different models and still have the same methods like .invoke. Everything is sort of, cross-compatible, meaning that you don't have to worry about the different library implementations for OpenAI and their proprietary model library, or Anthropic if they have a library, stuff like that. With Langchain, it's just one library, and then you could switch between different, implementations or different providers, but at the end of the day, they still have the same method, so it makes it all consistent, all right? But yeah, that's how you can invoke a model to get a response, pretty easy. If you want to, you can provide more settings as I told you before, so the model name, you can do things like the temperature, the max tokens, the top P, the frequency penalty. These are just extra settings, more advanced settings that control how different the responses are and stuff like that. It's not really something we're going to focus on in this series, but the options are there if you want to, okay? All right, the next thing I'm going to show you is pretty cool. It's called prompt templates. This allows us to have templates for our prompts so that we can dynamically inject values into it. So we can do, for example, Langchain core.prompts import prompt template. Now we could do prompt is equal to prompt template. And now to this, you can provide just a string. So we could say, for example, template, and we could say translate the following text to French. And then we could do input like this. So this is kind of like a variable pretty much. You can also do from template if you want to. I'm just showing you that because you're going to see a lot of examples of people using it like this, but you can also do it like this now as well, okay? Now that we have a template here, we want to chain it with the model so that when we call the model, when we invoke the model, like we did here, we can pass in that actual value. So let me show what I mean. So we could do chain is equal to prompt, and then the pipe symbol, and then LLM, or you can also do model, whichever one you prefer. And then once you do that, now you could do chain.invoke, And this is the part where you pass in what the input is going to be. You're going to do it as a map. And so you'll do the variable name or parameter name, whatever you want to call it, and then the actual value. So we'll say, I love programming. Let's go ahead and run it. And we get Jame programmer. So I don't know French. I don't know how to pronounce that, but we'll talk a little bit more about chains in the future. But basically, we're connecting this prompt template that we've created above to our model so that when we invoke the chain, we're going to automatically replace the variables with the actual values and then also pass that into the model. So in other words, since we chained it together like this, we're invoking the prompt and the model at the same time, but sequentially. So we're doing the prompt because we need to build the prompt first and then pass that new prompt into the model. So that's kind of how that works. Hopefully that makes sense. We'll have a dedicated video on chains in the future, okay? So if you want to, you could also replace French with language. And then now you could add that as one of your variables. So you can do language, and we can say Spanish. So now it's going to be translate the following text to Spanish, and then I love programming. Me encanta programar. Pretty cool. Now, a lot of the time when you're working with large language models, you want to give it a system prompt, which is just a set of instructions that the model will follow when giving you a response. So for example, you can have a system prompt that tells it to respond only in Spanish, or pretend to be like a wizard or something like that. It's literally just telling the model how to act, essentially, okay? So the way that we can do that with Langchain is to give it a list of messages. This is also useful if you want to have a message history that you want to build upon. So let me just show you what I mean, it'll make more sense. So we can do, for example, messages is equal to, open that up, and now you just want to do a set of messages. Each message is going to be a tuple that has the role name, so for example, system, and then the content of the message for that message. So we could say, for example, you are a helpful assistant that answers questions about US history, something like that. And then we could add a user message. This would normally be part of the prompt. So user, and then we could say, what is the name of the first president? So the system message will tell the large language model what it's supposed to be doing, and the user message is just any message that you would send to the model, such as the ones that we did here, like what is the capital or hello. These are user messages, okay? So now to invoke the model, we can do the same as before. So model.invoke. Instead of passing in a string, the user message, since we have a message history, we can pass in messages. So let's run it. And there we go. The first president of the United States was George Washington, blah, blah, blah. Another way that you can do this, though, that you'll see commonly is replacing these tuples here with actual types. This is something that people prefer because it's more rigid. So we're going to import human message and system message from Langchain core messages. And so now we're going to take this string here for the message and just replace it with system message. And this will be the content of the message. So like that. And then now, of course, for this one, for user, this will be human message. Okay, that's our human message now. So now if we invoke it, it works the same way. The cool thing about these as well, since it's a type, it automatically handles setting the role for you, as you can see. So you don't have to worry about making sure the role is a user or system or whatever. You can also use an AI message. So AI message, which is actually the type returned by the invoke, right? AI message, because that kind of makes sense. The AI is responding, so you get an AI message back. So we can add that to our message history to make it so as if we already talked to it previously. And let's just say something wrong, like 20 years old. And then we're going to add a new human message and say content that doesn't seem right. So now that we have a setup like this, we basically have a message history that shows that we've already been talking to the bot. So when we invoke the model with these messages, it'll just respond as if it already said these things, essentially. So let's run it and see what happens. There we go. So it knows what I said previously. And it says, I apologize for the confusion in my previous response. The United States was founded, blah, blah, blah. It's 247 years old. So there we go. That's how you can just use these message types and also message history to invoke the model with. All right, so one more thing I want to show you guys is how to combine message histories here like this with our prompt templates that we did before. So instead of a prompt template, we're going to be using a chat prompt template. So if we're going to be having a template for the human message or system message, we can do human message prompt template and system message prompt template. If you're not planning on modifying dynamically the system message, then you could just, not import it and not use it. So I'll just paste this example here. So the difference here is that instead of having just a list by itself, we're using a new type chat prompt template, passing in a list to it, and then now each item of the list is going to be our different messages, like the system message prompt template. We could do from template, and here's our template. You are occupation, name's name, get into character and pretend to be this role, answer questions accordingly, and then human message prompt template, from template, and then the input. Now that we have our template, we can now chain it together, same as before with our model. So chain is equal to prompt model, Now we can invoke the chain. So chain.invoke, pass in our values. So we want, first of all, an occupation, which is going to be old wizard. We also want a name. So we're going to say name, and we'll say Lord Aquarius. And then finally, we want the input from the user, which is just going to be, it can be anything. We'll say input hi, and let's see what we get. Let's run it. Greetings, young seeker of wisdom. I am Lord Aquarius, keeper of ancient secrets and arcane knowledge. What inquiries dost thou bring forth to my venerable self today? So yeah, as you can see, it works perfectly. It's in the character that I told it to be, which is a old wizard named Lord Aquarius. And we're able to do this using chat prompt templates. And since we want to modify our system prompts dynamically, we're going to use a system prompt template. If for some reason you didn't want to modify the system prompt, you can just remove all this, delete that, and just use system message, same as before, and just replace these template variables here with old wizard and then Lord Aquarius. There we go. So now if we run it, it still works. The key here is that if you're doing any templating at all with these messages, like human message or system message or AI message, you need to wrap it with a chat prompt template, okay? I'll give you guys a simple example of how we're going to be using RAG with the stuff that we learned today. The main part of RAG is invoking a model to get a response, but also providing context so that the model can give you an informed answer. So we can imagine a system prompt like this. You are a helpful assistant that answers questions. Only use the context provided to answer questions. If the context does not provide the answer, say I don't know, and then context, and then the context variable. So you're injecting that context in, and then we'll just provide a simple user input. And then now to invoke it, we're going to pass in the question. So what is the capital of the United States? And the context is going to say something totally wrong. The capital of Germany is Berlin. So we told it though that if it doesn't provide an answer in the context to say I don't know. So if we run it now, I don't know. If we change it to what is the capital of Germany, the context does have the answer, so it'll say the capital of Germany is Berlin. This is sort of the last step of RAG. The hard part will be getting the context and providing that when we invoke the model. Because when we do RAG, we ask a question, we search our vector database for related information. If we find any related information, we'll include it as context and then invoke the model with the question along with the context and get an answer. So that's the basic idea. Just a very simple example. It's going to be a little more complex than this, but hopefully you guys found this interesting. Now you guys know how to invoke chat models using Langchain. It's pretty easy, right? It's pretty fun. So thanks for watching, everybody. Alright, so I showed you guys in the last part how to work with chat models with Langchain. I showed you specifically how to use the OpenAI provider so that you can talk to ChatGPT using Langchain, but I want to show you guys also how to use Ollama, which is a place where you can get open source models. So if you go to ollama.com, go to models, you can view all of the models. The most popular ones right now at the time of recording is DeepSeek R1. It's, taking the world by storm right now because of a bunch of reasons. We'll see how to actually use the models in a second, but first go back and download Ollama just by clicking download and go through the installation process. Once you have finished that, then now you can go to models. So if I want to try DeepSeek, I can click into it and then it tells you more information about it, or even Llama from Meta or Facebook. They have their own open source models, which are really popular as well. So if you go to one of these, you can see that there's a bunch of different versions of this one single model here, because the full model, this one here, is 404 gigabytes, which is not something that you can expect to run on your local machine. That's absolutely insane. This is something that's supposed to run on a very powerful set of machines, so can't really do that. So they have these smaller distilled models that are smaller in size with still a lot of capability, and it goes all the way down to 1.5 billion parameters. The one that I can probably download and run on my machine without too much trouble is the 7 billion one, but even that I've tested is really, really slow. Maybe there's some ways I can optimize it. But you can also do the 1.5 billion, which is going to be way faster because it is smaller, but of course, less quality. So basically, you just choose the model for your use case, whatever kind of resources you have access to in terms of compute, and also the quality that you should expect from the model. Anyways, once you have the model that you want, you simply select it, and then it will tell you what command to run. So Ollama run DeepSeek-R1 colon 1.5b for that specific version of it. So copy that, and now you just want to open up a terminal. So I'm going to go to PowerShell, and now we can run it. So we'll paste the command and press enter. So what this will do is pull the model down to your machine if you don't already have it. Another way you could pull it down is by doing Ollama space pull and then the name of the model as well before you run it. I already had it downloaded, so now I can just directly talk to it. So I can say, hey, and now I'm talking to the CCP. Hello, how can I assist you today? If you want to exit out of this, then you can do Control D. That will terminate that session essentially. So that's all you gotta do in terms of like downloading Ollama, setting it up, and actually using a model. Pretty cool. But we actually want to use an application, right? So we're gonna use Langchain, specifically the chat Ollama provider, which allows us to use our Ollama models that we've downloaded directly inside of Langchain code within our Python notebooks and stuff like that, okay? First things first, make sure you have Langchain-Ollama and Ollama installed. All done, so now we could do from Langchain Ollama, import chat Ollama. Chat Ollama. And then now we can do LLM is equal to chat Ollama. And to this, we specify, a bunch of different settings, but the most important one is the name of the model that we want to target. So we could do model is equal to, and we want to make sure that we get the exact name for it to work. So if you do Ollama space a list, you can see a full list of all the models that you have locally. So we could do, for example, let's do Llama 3.1 latest. So Llama 3.1. Since it's the latest, you don't have to put latest. You can just do Llama 3.1. So I'll do Llama 3.1. And now to use it, it's the same as before, same way we did it with Chat OpenAI. Since they both use the Langchain interface for chat models, you just call the same methods. So we would do llm.invoke and then pass in whatever you want to say. So we could say, hey, and let's see what we get. There we go. It says, how's it going? Is there something I can help you with, or would you like to chat? Awesome. And if we want to, we can use the same template stuff we learned about last time. So we have a set of messages here with templates within it that have variables, and then we can, chain the prompt to a large language model, which is our chat Ollama model. And then now when we invoke the chain, we pass in the occupation, the name, the input, and this will give us a response. It should be like a wizard. Greetings, young one. I am Lord Jaquarius, a wise and venerable wizard of great renown. So it works perfectly. So that's it. That's just an example of how you can use a different chat provider, chat model provider like Ollama, which is a very popular one because it allows you to run models locally on your machine for free. You don't have to pay for anything. As long as you have the resources to run the model, you're good to go. If you don't want to use OpenAI or you don't want to use Ollama even, you want to use a different provider. As we saw before, there's a bunch of different ones out there. But that's it. Thanks for watching, everybody. I'll see you guys next time, and peace. Hey guys, welcome back to the series on Retrieval Augmented Generation using Langchain. So before, when I gave an overview of what RAG is, I told you that there's two pipelines, the indexing pipeline and the generation pipeline. We're first going to zoom in on the indexing pipeline. And this pipeline has the responsibility of loading, splitting, embedding, and storing documents or data for later retrieval. So even though it's called Retrieval Augmented Generation, there's steps before that, which is indexing. So it's indexing and then Retrieval Augmented Generation, all right? So ingesting documents goes like this. First, we're going to load documents, and a document can be anything that can be converted to text. So when we talk about Langchain documents specifically, it's going to be something that has text and then metadata. Every document will have text, but then the metadata will be stuff like the source, the page number, if it's like a PDF, for example, or a book. If it's a website, it could be the URL, just information like that could be later useful for your documents. There's different types of document loaders that give you documents depending on the source of where you're trying to get the documents from. So again, if it's a website, a PDF, an EPUB file, a CSV file, a text file, all kinds of different data formats that can be imported as documents. So once you have obtained your document and loaded your document, you then want to split it into chunks, otherwise known as text splitting. This means that you're going to take your documents and split them up into smaller chunks or just smaller documents with less text size to make them more manageable. And we're going to see why that's so useful. But once you have your documents split up into more manageable chunks, you're then going to embed them into numerical vectors so that we can then store them within a vector database. The reason we want to convert our text into embeddings is because we can then compare them using things like cosine similarity to see which queries match closely to which document chunks. It's not going to make a whole lot of sense me just explaining it now, but once we get to that part, it'll make a lot of sense, okay? So once we have loaded and split and embedded our documents and stored them into a vector database or a vector store, later on we can then do retrieval for retrieval augmented generation to retrieve relevant chunks to provide to our generation pipeline. So I hope that makes sense to you guys. Let's get started now learning how to load documents into our application using Langchain. Alright, now that we know what document loaders are, they are a way to load external information into documents that store text and metadata. Let's get started. So we'll take a look at this link in a second here that shows a bunch of document loaders that we can use, but the most basic one that we could use is the text loader. First, let's just make sure that we have Langchain installed, and then after that we can now do from langchain.document loaders import text loader. Now to set up a document loader, we're going to do loader is equal to text loader. And to this, usually provide the sources of where you're going to load it from. In this case, since we're loading text files, it'll just be the name of the file or the file path. So we'll do test.txt. We don't really have anything, so let me go and add a file real quick. We'll do new file, test.txt. Alright, so I've got a couple of paragraphs here of just random gibberish, just lorem ipsum gibberish. Now to load it in, we're going to do documents is equal to loader.load. So first you'll just tell it what you're going to load, and then now you're going to call load, and this will actually load the content of this file here into multiple documents. It's documents plural because sometimes you're going to be loading from multiple sources, but also if you're loading from one source, let's just say it's like a PDF or something like that, it may break it up into multiple documents per page, for example. So you can expect this to return multiple documents, okay? So once you have that, now we can go ahead and print the first one. Let's just take a look at what it looks like. So we'll do documents and just get the first one. There should only be one anyway. Before we do this, actually, we need to make sure that we add one more package. That's going to be Langchain Community. This is going to have all of our document loaders inside of it. So let's run that to make sure we have Langchain and Langchain Community. All right, it's done. So now we can run it. Here we go. We get our document. So we can see it's a document type. It has metadata. So the metadata contains one field, which is source, and then the source file. So it just tells you where it comes from. And then more importantly, we have the page content field, which includes all of the text content of the document that we just loaded in. So if you want to print only the text, you can do page content, and there you go. So every single document that you have, since it's a document type, it's going to have metadata. The metadata could vary. It does vary between different document loaders because different document types have different information that's useful. In this case, it's just a simple text file. The only thing that it's going to have in this metadata is the source of the file, but you can expect different types of information. But besides that, you'll also have the page content always, okay, which is the actual text. So that's how you can use a document loader. And between all the different types of document loaders that we're about to test out, it's pretty much the exact same between all of them, since it's, extending from the document loader type. You tell it what to load from what source, and then you call load, and then you have your documents, all right? So with that said, now let's go to this website here and take a look at the different options that we have. All right, so document loaders. You can see there's a lot of them. You have web page document loaders. That one's pretty important. You have PDF document loaders, cloud providers, so you can load from like Azure blobs or AWS blobs, Dropbox, Google Drive, Twitter, Reddit, all kinds of different things. So it's really insane how many there are. There's even more than this. I'm pretty sure you can find some third-party ones even outside of this list here. So the key here is that you're going to have often different types of data, like you want to load from a website or a PDF or an EPUB file, all kinds of different things. And Langchain provides all these providers here that allows you to load that into documents. So as long as you can get your data into a document, then you're good to go, because a document is what we use to, load into a vector database and all that fun stuff that we'll be learning about, okay? Anyway, so let's just take a look at some of these. Let's see how we can use the web document loader, the web-based loader, to load websites into documents. Yet again, the documentation is very helpful here. It tells you exactly which packages you need, because you may just try installing Langchain Community and forgetting to install Beautiful Soup 4. So just make sure that you check the documentation always to see that you're not missing anything, okay? After that, it'll just tell you actually how to use it too, which is useful as well. So let's just copy this package name, make sure we install Beautiful Soup 4. Let's add this on like that, and let's rerun this to make sure we get all those packages. All right, so now we can load a website. Let's do it now. So we're gonna do from Langchain Community. Make sure it's from community this time and not Langchain, because this is a community document loader. So Langchain community.document loaders import web base loader. And then now we could do same as before, loader is equal to web-based loader. We're going to tell it what to load, so we're going to find a URL. So for example, we can just take this URL for this documentation here, and let's use that. So it should load all of the content of that website into a document for us. Let's see if that works. So documents is equal to loader.load, and then we can do documents 0. Let's see what we get. All right, that was fast. So we got our document. We can see that as metadata of the source, which includes the URL. It also includes the title of the website, which is useful as well. So web-based loader from Langchain. And then also a description. So it says this covers how to use the web-based loader to load all text from HTML web pages into a document format that we can use downstream. It also includes the language. So as you can see, this one has a lot more useful metadata. And then we get down here to our page content, which is the actual text that we've grabbed from this website. So let's just print that content, page content. So obviously it's a little hard to look at just because it's formatted all into one line here, but yeah, we can pretty much see that it's all the text of that website that we specified. So that's just one way you can load information using the web-based loader. If you want to, you can load multiple websites at once. It will load into multiple documents. So let's run this. And then we can just print the length of it just to verify. Should be 2 because we have 2 websites. So go ahead and print out the content of the first document, which is espn.com. Let's take a look. So this one's just a lot of white space. There are ways to clean this up. There are formatters and stuff you can add onto this, but I'm not going to focus on that in this episode. The point is that you can load the content of a website. Sometimes though, it's not going to load the information you want. As you can see, this one's mostly white space, so it's less useful. So there's different document loaders that are more detailed. It can extract more information from the page. The point of this episode, though, is just to show you that you can do this. There are different document loaders. Okay. So the next document loader I want to show you guys is the CSV document loader. If you don't know, a CSV file is a comma separated values file. So you just basically have a bunch of rows, and each row separates the columns by a comma. So unique ID, indicator ID, name, measure. This is just a air quality data set essentially. So tons and tons of data that you would use to do like machine learning or something like that. So we can load this into a document as well. We're going to import Langchain community.documentloaders.csv loader, import CSV loader, and then now we can do loader is equal to CSV loader. We're going to specify the file path of the file that we're trying to load, which is airquality.csv. And then now you can also specify the content columns. So whatever column names you specify here is going to be the column names that are loaded into the page content of the documents. So for example, if I do just a name, it will only load the names. Okay, so let's try that out. We'll do documents is equal to loader.load. And now what I'll show you is I'll print the length again, and you'll see that it's very different than before. Let's try this out. So we get 18,000 documents. This means that every single row of our CSV file is going to be a single document. That's just how this particular document loader works. And if we just go and take a look at a single example here, we'll do documents, we'll do the first one and get the page content of it. We can see that it has the name, only the name. So it's this one here, boiler emissions. Interesting. So if you want to load other ones, of course you can. You could do like the measure info, for example. So we'll add that measure. So look at that. Now we have the other information as well. So that's just an example of using a CSV loader if you want to load CSV file data. Another one that's pretty cool is loading PDFs. So make sure that you do pip install py-pdf. And then I have a copy of Moby Dick as a PDF file in my folder here. And so we'll load it in using the py-pdf loader, specify the file name or the file path. We're going to load it into documents. And then the number of documents is going to correspond to the number of pages in the PDF. So I think that kind of makes sense. One document per page. And so then we'll just print the first 500 characters of the first page. I did the 7th index just because the other pages before that are just going to be like table of contents and stuff like that. So first it's just installing the package, and then you can see here the contents. So call me Ishmael some years ago, never mind, blah, blah, blah. So that's the first 500 characters of the first page. There's a total of 468 pages. So that's a basic introduction to document loaders with Langchain. Now, generally speaking, no matter what data source you have, you should be able to load it into a document, a Langchain document using these data loaders here. If you have a data source that I did not show you how to load, then just simply check the table here to see if you can find one. If it's not here, there's probably one out there anyway that you can use. So that's it. Thanks for watching, everybody. Alright, so we're going to learn how to do chunking, which is also known as splitting documents into smaller chunks of text for processing. Chunking or splitting, same thing. So the idea though is that we want to take our documents that we've loaded from a data source, from a document loader, and make them smaller, breaking them up into smaller documents. So just as an example here, we're going to text load this text document that we have here using the text loader, and now we have it in a single document. Make sure that you've installed all the necessary packages like Langchain, Langchain Community for the text loader, and then Langchain text splitters for the text splitters. Now we can do from Langchain text splitters, import character text splitter. This is the most basic text splitter you have available. This will split text based on a single character. So let me show you what I mean. So we'll do text splitter is equal to character text splitter. We want to give it a chunk size. When we split up the document into chunks, this is the amount of characters per chunk, or the maximum amount that it will try to achieve. It will try not to go over that essentially. And then we can also specify the chunk overlap. Overlap is necessary to make sure that we do not lose any information. I'll explain more about that in a second, but a good default value is 200. And then most importantly, we're going to specify the separator, which is the character that we're going to use to split the text. So we're going to do chunks is equal to text splitter dot split documents, simply passing the documents that we're trying to split, which in our case will be the single document from our text file, and that's it. So that will actually do the splitting, output it into new chunks, which are just more documents, and then let's just print the number of documents that we now have. Now we need to run this first. This is all the text that we loaded from the file, so let's try splitting it now. There we go, we get number of chunks 5. So what this is doing is basically going into the document, which has the contents of this here, and every time it reaches our character, which in this case is just a new line character, which would be a line break, it's going to split that into a unit. And what it will do is try splitting it enough so that it gets under 1000 because that's a chunk size. So it's going to try splitting it enough so that every single chunk does not go over 1000. Let's go ahead and print out each of the chunks along with their size. So this first one here has 796 characters. That's all the text within it. Then this one has 751, 839, 835, and 334. So because this is the last one, obviously it's probably going to have less because it only has so much text left to provide to that chunk. But the key thing here is that we've taken a single document with a bunch of text in it and split it up into 5 different documents that are below 1,000 characters. That way our data is more manageable. This makes it much easier for us later when we have to do retrieval for retrieval augmented generation. It's much easier to search through a bunch of small documents that have smaller amounts of text than a single document with a massive amount of text. So we'll see about that in just a little bit. So that is the character text splitter, is the most basic one. The issue with this one is that you can only specify a single character to split based on, right? A lot of people instead will use something called the recursive character text splitter. That one is better because it's able to break up the documents based on a couple of different characters, not just a single character. So for example, an issue that we have with the character text splitter is if you want smaller chunk sizes, just as an example here, if we run this now, we see that we have more chunks, right, because they're smaller now. But once we get to the end, it says created a chunk of size 554, which is longer than the specified 500, says it twice. This is because if you have only one character to separate on, it can only break it up so much. At a certain point, this piece of text here, this paragraph, could go on much longer than 500 characters without reaching a line break. The reason we use the new line separators because obviously lines should go together. If we're going to chunk our data into different chunks, we should keep the sentences and the paragraphs together as much as possible. But at a certain point, if a paragraph or a line is too long, it won't fit within a chunk size of 500. So that is where the recursive character text splitter comes in. So for this one, we're going to load a different data source. We're going to load the US Constitution from this URL here as a .htm file using the web-based loader. So let's print out the contents. So it's just a big text document essentially that has the entire Constitution in it along with our amendments. So yeah, this could be something that you may want to build a RAG thing based on, so you can ask information about our Constitution. So you can imagine that if we have a chunk size of maybe like 1,000 or just any number, for example, if this Constitution here has very large paragraphs within it, then using the character text splitter with only a single separator of just new line may not be sufficient to break it up into chunk sizes of say 500 or 1,000. So having a recursive text splitter can help us solve that. So we're going to bring in that recursive text splitter. We're going to instantiate it by doing text splitters equal to recursive text splitter. We're going to set a chunk size of 1,000. We're going to set a chunk overlap of 200, and then we'll also set our separators. And now this one accepts multiple separators as I told you. So this here is actually the default. If you don't specify any separators, it'll use this anyway, but actually putting it here I think is more clear to you guys. But as you can see here, now we have multiple separators, and it's called recursive because the way that it works is it's going to go through our document, and it's first going to separate based on the double new line here. And then if there's any chunks that are not below our size of 1,000, it'll then go to the next separator, which is just a single new line, and break it up based on that. And then if it can't, bring it down to below 1,000 still, it'll go to our space, and then finally by character. So the effect of this, going through all the splitter characters and splitting the text until they're in small enough chunks, is that it keeps all of the paragraphs together, and then the sentences, and then the words, as long as possible. It's not going to immediately split down to a word or whatever. It's going to try separating based on paragraphs first with this one, and then single lines, and then sentences, and then words, okay? That's the effect of it. So it tries to keep these units together as much as possible, but if it can't, it just breaks it down more, because we need our chunk size to be a maximum of 1,000. So to actually use it now, we'll do chunks is equal to text splitter dot split documents, and we'll do documents. Nothing happens, that's good, no errors. So let's go ahead and do what we did above. Let's just print out the size of each document. So we can see that we have all these chunks here, and they're all below 1,000. We have 429 chunks. Let's take a look at a single chunk. So we'll do chunks 0.page content. So we see a bunch of stuff here. Okay, not very insightful, but the point is that it's a chunk of a previous document. This one's a little more interesting. The recursive character text splitter is one that you're going to see way more often than just the character text splitter. It's a very good solution to break up your documents into chunks, to split up your documents. Now I want to talk to you guys about what chunk overlap is and why it's important. When you specify a chunk overlap of 200, this essentially means that it's going to try and maintain a overlap of 200 characters between a chunk and the next chunk. Here's an example of what I mean. We're going to print out the end of chunk 4, so the last 300 characters, and then the beginning of chunk 5, so the first 300 characters, and we should see overlap of about 200 characters. So just reading through this, you can see that the overlap is ending here. So it says and approved by 13 states, and then and approved by 13 states all the way up until here. And then here's the new information in that next chunk. So that is what I mean by overlap. So now that we understand what overlap is, the reason that it's important is because if we have situations like this where we just have a sentence that is cut off because the next chunk is beginning, if the next chunk just started where it cut off and then didn't include the beginning of the sentence, then you would lose that important context. So it's important to have the next chunk include a little part of the previous chunk, which is overlap, so that you don't lose any important information. I think this example from Reddit is actually a really good one. So if you have two different chunks, one says blah blah blah, I have a cat allergy, so I would never say anything like, and then the next chunk says I love cats, blah blah, and then you ask a question, does this person like cats? Looking at our chunks here, this one obviously says I love cats, right? So this has to be the answer. Yes, they love cats. That's because there's no overlap, right? This chunk here does not include any text from the previous chunk. So if it had overlap and it said, so I would never say anything like, I love cats, blah, blah, then the answer would obviously be no, which is the correct answer. So all that means is that if you don't have overlap, you lose important contextual information. In this case, it was the beginning of the sentence, so I would never say anything like, I love cats. So that is why we need overlap between our chunks, okay? So there's one more type of splitting that I want to show you guys, which is document structure-based splitting. So this is for specific document format types like HTML, Markdown, JSON files, where a file has a specific text structure that it follows. So we can basically, if it's an HTML file, break up the HTML file by, headers or divs, different elements of the HTML file. Or if it's a markdown file, we can split it based on headers as well. So that's why it's called document structure. I'll be showing you guys how to work with the markdown splitter just as a basic example, but there's plenty of documentation for all the different document types that it supports. So make sure to check out the documentation. So start by bringing in the markdown header text splitter. So what it will do is split up your document if it's a markdown file based on the headers inside of that. So if you don't know what Markdown is, well, I hope you would know what Markdown is because that's what these blocks here are for, the Markdown blocks. This is the top level header, so this, and then the more hashtags you add, the deeper it goes in terms of the hierarchy. I don't know how many there are, but those are the highest three. And so if you have a document like this, let me paste it. Let's just say that you have a document like this with a foo header, and then under that you have a bar header. It's two hashtags, so it's smaller than this one. And then it has some text, multiple lines of text, as you can see. Then there's going to be a boo header with three hashtags, so it's smaller than this one. So that's even deeper in the hierarchy. And then finally you go back up to baz, which is two hashtags, which is back up to this level. So it's basically just a bunch of levels of a header hierarchy. So what we can do is specify the different headers that we specifically want to split on. So we want to target these top level headers here. So 1, 2, 3. And then if you want to, you can give them an identifier, which will show up in the metadata of the document. So now we'll do markdown splitter is equal to markdown header text splitter. Pass in the headers that we want to split on, which is what we just specified above. And then now we can actually do it. So we could say markdown header splits is equal to markdown splitter, and we'll say split text and then pass in our markdown document. And as you can see, we're using split text instead of what we used above, which was split documents. There's just a couple of different methods that you can sort of switch between. So if you have your markdown text within a document, then obviously you would call split documents. But in this case, since we just have it in a simple text, a string variable here, we can use split text, okay? So we'll say markdown document, even though it's not actually a document. So that holds the result. So we'll just go ahead and, print it out. So let's take a look at what we got. All right, so we have one document here, or one text here that was split into three different documents. And it's kind of tricky to understand at first, but it's basically split upon those header hierarchies that I just described to you. So for the first one, we can see in the metadata, it says header 1 foo, and then header 2 bar, and then it has page content, hi, this is Jim, hi, this is Joe. So basically what it's doing here is it's finding the top level header, so foo, there's a text for it, that's what it's specifying here, and then it's going to the next level down, which is bar, and then the text for that. So, hi, this is Jim, hi, this is Joe, and so that'll basically just be one document split, but then you have the next level under that, so you have foo, bar, and then boo, so boo is the one with the three hashtags, so it's going even further, including that text. So, hi, this is Lance. That's the text specifically for that deepest layer. And then for the last one, we have foo and then baz. So it's the top level one. And then instead of bar, because that we already covered that one, we're now going to baz, which is the second level header. And it's just adding the text for that. So hi, this is Molly. So like I said, it's a little tricky to understand. Hopefully I explained it not too confusingly, but basically the idea is that it's going through as deep as it can through all the different headers of the markdown document. Okay. So this is just one example of a document structure type splitter. Like I said, there's other ones for HTML, JSON, whatever you need, okay? So check those out if you need that. These are useful if you have specific files that you're sort of ingesting and they have specific formats, all right? There's one last important question that you should be asking at this point, which is how do you choose the proper chunk size for your splitting? How do you know what number to set that to? So, just like everything in machine learning and AI, it really just depends. It's a trade-off because if you have a model with a high context window, this means it's able to handle more text, more tokens. So you don't need to have as small chunks potentially. But if you have a model with a limited context window, then it can only handle so much information, right? So having smaller amounts of information makes sense, so a smaller chunk size therefore. But also at the same time, when thinking about the chunk size for our splitting, we want to consider the format and structure of our documents. So if we have a blog article, for example, it would make sense to try and split based on maybe the paragraphs because we want to keep related ideas together, right? Because when we're trying to feed this context later to a large language model to be able to answer a question, we want it to be not just a single sentence or part of a sentence, but all of the relevant contextual information that it would need to answer the question effectively, right? So there's no one size fits all answer for this. It's really just something that you kind of have to experiment with at the end of the day. But just as a general rule, you want to try and limit it as much as you can, but also keep related ideas together. So start with a chunk size that feels reasonable. So I would say a few hundred, chunk size. Test it out just to see how that does, and then pay attention to whether the chunks retain enough context. If it's cutting off too much information, then maybe you need to adjust it to make it a little bit larger, right? So I hope that's a little insightful. So that's it for this part. Thanks for watching, everybody. Now you guys know how to split documents using Langchain. Hey guys, welcome back. So now we're going to be talking about embeddings. So in our indexing pipeline that we've been working on, we've learned how to load documents, we've learned how to split documents. Now we need to learn how to embed documents. So embeddings are simply text, they're document text encoded as numerical vectors. So a vector, if you don't know, is just a array of numbers. This is a vector of size 3 because it has 3 different values, and it's just numbers. Because even though the documents that we've been working with contain text, machine learning and computers in general like to work with numbers. So we need a way to translate our text into numbers, but at the same time retain any useful information like the meaning of the text, right? So in this case, we're going to be using something called an embedding model that will take text like words, for example, or even sentences like dog, cat, potato, and what it will do is translate those pieces of text into embeddings or numerical vectors, okay? So dog could be something like this, just a bunch of numbers. Cat can be something else. Potato can be something else. It's all about representing it as numbers, but without losing meaning. So no matter the length of the text that you feed into the embedding model will always spit out a vector of the same length, otherwise known as the number of dimensions. So for this example here, this embedding model will spit out embeddings where the number of dimensions is 3. Realistically, the embedding models that we'll use in the real world will be much larger. They're not going to be 3, they're going to be like hundreds of dimensions or even thousands. So besides just being a bunch of numbers, a text embedding will encode the semantic meaning of the text that it, represents. This allows us to see how close together different words are or different pieces of text are in meaning. So as an example here, if we stick to our 3-dimension example, so every text embedding will be, size 3. If we plot dog, cat, and apple, dog and cat should be close together in 3D space because it's 3 dimensions, right? This is because a dog and a cat are both animals. They're similar. They're often used together in sentences, you could say. But then apple is totally unrelated. An apple doesn't really, relate to a dog or a cat. It's not even an animal. It's just a fruit, right? So mapping the embedding vectors like this in 3D space allows us to visualize how close together words are in semantic meaning because that's exactly what we will be doing. I'll explain that more in a second. Here's another example here. So if we have different words like man, king, woman, and queen, you can see that at the extremes here we have man and queen, and then we have king and woman in the middle. So for king, it kind of makes sense for a king to be in the middle because it's kind of related to a queen. Kings and queens are, they kind of go together, but also a king is a man, so that also should be close to man. But a queen doesn't really relate to man at all. So that's why it's so far away. So it makes sense for a king to be sort of in the middle between man and queen because it relates to both. And then for woman, it's kind of the same thing. So a woman is often related to a man, but then also a woman is a queen and such, okay? So like I said, the embeddings that are closer together will be more semantically related, meaning they mean the same thing essentially or related in terms of their meaning, okay? So if an embedding encodes the semantic meaning of a piece of text, you can utilize something called cosine similarity to see which embeddings are closely related. So just to translate, all that means is that we're using a formula called cosine similarity, which will actually give us a number that computes how closely related two different embeddings are. This one should have a lower score, which is better, versus dog and apple, which should have a higher score, which is not as good because they're less closely related, right? It's literally just calculating the angle in space between two different vector embeddings, okay? So there's thousands of embedding models that we can utilize. There's open source ones, there's proprietary ones like OpenAI. There's an entire leaderboard that we'll be taking a look at where you can see all of the different embedding models available. So here's a few of the OpenAI embedding models, just because, it's so popular. So we have the model name, so text embedding Ada 2, text embedding 3 small, and text embedding 3 large, which are the two latest embedding models for OpenAI at the time of recording. So here you can see the dimensions. So as we learned, this is the number of dimensions for each embedding produced by the model when you feed text into it. So every embedding that comes from this model will have 3072 dimensions. So for max tokens, this is the max amount of tokens that the embedding model can take at a time, which is also why splitting up your documents into smaller chunks is important, because you want to make it so that you can process it in this way. And then we have a knowledge cutoff, so it's not really going to be able to understand concepts beyond this point. Any new concepts like, I don't know, do you have Riz or something like that, whatever the kids say nowadays. And then we have some metrics here like Miracle Average or MTEB Average. We'll be taking a look at the leaderboard for this one here. So those are just 3 different embedding models that we can utilize from OpenAI. Like I said, there's a bunch of them. So now that we understand what embeddings are, they're encoding text into numbers, and also how we can use them with cosine similarity to see how two pieces of text are similar. This is where vector DBs come in. A vector DB or vector database has 2 main roles. Number 1, it's going to be storing our embeddings. We just need a place to store them efficiently. The second responsibility of the vector DB is to take a query or an embedding for a query and match it against the embeddings of the database to produce the embeddings that are most closely semantically related. So as an example here, if we have a query favorite sport, we can't just match the text favorite sport against all these embeddings here because it's just numbers, right? What we can do is first encode that as an embedding itself, so run that through the embedding model to get an embedding for that, and then we'll give it to the vector database to match against all the stored embeddings, and it should produce I like football because that's obviously going to be the one most closely related to favorite sport. This whole concept right here is the R in RAG, retrieval. We're taking a query and finding the most closely related documents that we've stored as embeddings into our database. Then once we have the top results, we're going to give that to a large language model along with the original question, like favorite sport or whatever the question is, and ask the language model to use that along with the context to answer a question. So that's why this is so important, okay? So now that we understand what embeddings are, what vector databases are, we're going to learn how to compute embeddings for pieces of text or documents, and then we'll learn how to store those embeddings into a vector database and then query that vector database. So hopefully you're excited for that. Let's get started. All right, let's talk about how to do embeddings with Langchain. So the first link that I want to show you real quick is this embedding models documentation page so that you can view a list of all the embedding models that Langchain has as a provider. Just like our document loaders, we have a bunch of different providers here that allow us to calculate embeddings from different embedding model providers. So for example, if you want to use an OpenAI embedding model, you just need to install the provider for it, and then you could use it like this. If you want to do something like Google has their own embedding model, so you could do it like this, install this one and use it like this. There's a bunch of different ones like NVIDIA, AWS, just a bunch of different companies have embedding models for you to use, but then you have a full list down here of a bunch of different ones. A very popular one is Hugging Face. This is where you can get a lot of the open source models. In fact, they have a leaderboard that I've been talking about previously that shows you all of the top models and their performance. So you can see it's just a bunch of models here and their names, and then you have different information like the model size in terms of their parameters in millions. So the larger the size of the model, the harder it's going to be to download and run just because it takes more resources. And then also your memory usage in gigabytes. The top one takes almost 30 gigabytes, which is a lot. Then you have other metrics that I told you about before, like embedding dimensions. So the number of dimensions per embedding that is outputted by the model. And then after average, you have a bunch of other metrics which are basically data sets that are used to evaluate these models here. There's a lot to unpack here, but the average one tells you the average across 56 data sets. So I think that's a good indicator of how good the model is. So you can see that the top one currently is about 74% in terms of its quality across the 56 data sets. And so obviously the lower that you go, the less performance these models will be, okay? So besides that, you can also choose different embedding models for different types of tasks that you're doing. By default, it's going to be on overall, but you have classification, clustering, pair classification, which is when you're comparing two pieces of text to see how similar they are. re-ranking, and then retrieval. As it says here, retrieval is the task of finding relevant documents for a query, which is exactly what we're going to be doing. So this would be a good one to look at. And you can choose a different language. We're focused on English, of course. You can also filter by model types, like if it's an open source model, meaning it's free and downloadable, or it could be proprietary, meaning that it's provided by a company like OpenAI where you have to pay for it. So you can filter by those different options. So, anyways, with that said, just check out this leaderboard when you're trying to find a model to use for whatever you're doing. So let's see how we can actually use one of those Hugging Face models. So we're going to select Hugging Face. It's going to tell us which package to install. So I've got a new notebook here. I'm going to make sure that I install Langchain, Langchain Community, and Langchain Hugging Face so we can use this Hugging Face embedding models. So I'll run this. Alright, that's done. So now let's make sure that we load our document. Same as before, we'll load the constitution and then we'll split it up into chunks. So we have 430 chunks. Hugging Face, import, import, Hugging Face embeddings. Now we need to load the embeddings model. So we'll do embeddings model is equal to Hugging Face embeddings. And then we want to pass in the model name that we want to target. So since Hugging Face provides, those models for you to use, you need to specify which one you want to load in and use. A very popular one is all-npnet base v2. It's directly from Sentence Transformers, which is a Hugging Face library for embedding models. So you'll see a lot of models that use Sentence Transformers. So if you ever try doing embedding outside of Langchain, you can use Sentence Transformers directly to bring in models like we're doing here. So in this case, we're using Langchain and it does it behind the scenes, okay? So like I said, this is a very popular model, but you can swap it out for a lot of the different models on the leaderboard. Some of them you have to do extra steps for or install other stuff, but a lot of them are compatible. But once you have your embeddings model, now you can calculate embeddings for the different document chunks that you have. So we're going to do chunk embeddings is equal to embeddings model dot, and we could do embed documents, which actually just takes in a list of strings. So we still want to convert our documents into a bunch of strings, and we could do that by doing something like this. We could do chunk dot page content, and we could do for chunk in chunks. So all this is doing is taking each of the chunk documents that we have from above and converting them to a string, which is just our page content of each document. So that's it. That's how you take documents and compute embeddings for them. So if we have 430 chunks, it should give us 430 embeddings, but they all should have the same length, right? The same number of dimensions. So we'll just go ahead and print out the length for the first embedding to see how many dimensions there are, okay? Now, sometimes it could take a while just because, one, you have a lot of chunks, but also, two, you could have a embedding model that takes a lot more resources. There we go, finally finished after 45 seconds. That makes sense. It was a lot of chunks. And we got a dimension size of 768. So here it is on the leaderboard. We can find it at rank 158, so it's definitely a less powerful model, but it only has 110 million parameters, and the memory usage is also very low, so only 0.41. So this is a great model for if you have less resources available, and also if you want to compute the embeddings faster. And then with those limitations, it only has an average of 43 in terms of the quality of the model. But also you can see here that, like I said before, it has 768 embedding dimensions, which corresponds to what we just ran in the notebook. So that makes sense. Let's see if we can swap it out for a more powerful model. So we'll go back. Let's just remove this, search query here, and let's look at the leaderboard. So 30 gigabytes of memory usage is way too high for my machine. I think I have 32 gigabytes, but obviously that would use way too much. So I think we'll try using this one here. Number 6 is Stella. English, 1.5 billion parameters. Yeah, it has almost 6 gigabytes of usage, and then it has 8,000 embedding dimensions. Overall, it's just a much more powerful model. It has a very large max token size as well, so it should take a lot of text. And then also it has an average of 61 instead of, I believe it was 38 or something like that for the other one. So this should be a really good upgrade. So I'll click this one, and I just want to copy this name up here. You can click the copy button, and now we'll go back to our code here and just replace it. And hopefully this should be available to the Hugging Face embeddings provider here, so it should be able to download it and just use it automatically. So now I know ahead of time, before I even run this, because I've already tested this, that this is going to take a very long time because I have a lot of chunks, and also this is a very powerful model, as we saw, right? So what I'll do is just run it on a single chunk like this. So we'll do chunks 0.page content. So we'll run it on a single chunk to compute an embedding for it, and then we'll print out the size of that embedding just to prove that it works. So let's run it. There we go, finished after 13 seconds. So if it roughly takes one chunk to be converted to embedding 13 seconds, 13 times 430, that's a lot of time. So that's why, I did it like that. So as you can see, it's pretty easy to use these open source models, but we can also use proprietary models if you want to, such as OpenAI. We'll start by making sure that we have the OpenAI provider installed, as well as importing the OpenAI embeddings class here. And now we can make a new OpenAI embeddings model. So all we got to do for this one is, just like before, specify the model name that we want to target. So the default here you can see is text embedding 8.2, but we can do, for example, text embedding 3 small. So that's one of their newest models that I showed you before. Then if we want to, we can embed all the chunks, same as we were trying to do before. So what I'll do is copy this chunk embeddings, paste it like here, and now I'll replace it with the code that we had before. So we'll do for chunk in chunks. So again, we're looping through all of our chunks, converting it to a string, which is the page content or the text content of the document. And then we're going to embed all of them and output them as chunk embeddings that we can work with, okay? So we'll just print out the length of the first one, like so. All right, let's try this out. There we go, it finished. It was really quick, and that's one of the benefits of using a hosted model because their machines are much more powerful and can do the work for you much faster than, running it on your local machine here or hosting a machine yourself. So we can see that the dimension size is 1536. So again, every embedding that is outputted by this embedding model will have that size, okay? So we can print out the contents of a single embedding if we want to. Let's do that. It's just going to be a bunch of numbers, but I'll prove it to you. Here we go. We can see it's a bunch of numbers. So this is the vector of numbers that represents our embedding for the text that we gave to the model. Okay, so now that we understand what embeddings are, how we can actually compute embeddings using Langchain, now we want to move on to vector databases, which I told you before is a way to store embeddings and also query related embeddings, which we'll need for retrieval and retrieval augmented generation. Let's see how we can do that. So just like we saw with the embedding models, there's different providers as well for vector stores. So if we go down here, we can select vector stores like Pinecone. We could do in-memory. So Langchain provides a default in-memory vector store that we can utilize if we want to. There's also one by Facebook called FISS. I don't remember exactly what it stands for. If we click it, it can tell us more. Facebook AI Similarity Search. So it's a library for efficient similarity search and clustering of dense vectors. But basically, this is a vector store that Facebook provides as open source for us to use. It stores all the data completely in memory when you're using it, but you could save and load it from a file if you want to as well. So it's a great option if you want to. But for actual production applications, you often want to go with a different provider, like a hosted provider even, such as Pinecone, for example, or you can host your own vector database like Chroma. The point is that you have a bunch of different options here. Some of them are good for just local testing, like the in-memory vector database or FAS or FAISS. That's also good for that. But in terms of actually deploying an application and wanting to use it on a larger scale, you probably want to go with a different provider. That's why you have so many options here. But also at the same time, a lot of the basic ones lack certain features that the advanced ones have, such as storing metadata along with your embeddings. This allows you to associate different pieces of information with your embeddings so that you can improve your retrieval process. They just have a lot more advanced features. You can even see a table here of some of the features that some of them do and do not have. So at a minimum, a vector database is going to store embeddings and also allow you to query similar embeddings, but there are more advanced providers that give you even more features, like Pinecone, for example. That's a really popular one nowadays. So no matter which one you want to go with, just click it. It'll tell you what to install, how to use it, and all that good stuff. No matter which one you choose, since we're using Langchain here, at the end of the day, they all sort of inherit from a common interface. Once you have your vector store or vector database set up, just by the instructions as provided by whichever provider you choose, it's pretty much the exact same way in terms of actually using it because Langchain offers a common interface. We're going to experiment first with the Facebook FAISS one that I told you about before, so we'll make sure to install the necessary package for that. Now we can do from Langchain community, vector stores, import FAISS. Now we'll instantiate it, so we'll do vector store is equal to FAISS dot from documents. So the way that this works is instead of giving it your embeddings that you've calculated before, you actually don't have to calculate these yourself. The way it really works is you pass in your document chunks along with your embedding model, and what it will do is use that embedding model to automatically calculate the embeddings for all the documents that you pass in. So we could do, for example, documents is equal to chunks, and now the next parameter is going to be embedding, which, like I just said, is not the actual embeddings, but the embedding model itself. So we'll take that and provide it. So it's going to take all these documents, embed them using the embeddings model, and store them. And that's it. That's literally all you have to do to bring in our documents as embeddings into the FAISS vector store or vector database. So now we can do something like vector store.index.in total, and this will just simply print out the number of documents or chunks that we've indexed into the vector store. So let's run this. It takes a second because it has to actually do the embedding, like I said. So there we go, 430, which lines up because we passed in 430 chunks, and so it's going to store 430 embeddings. The other important thing is that since we're also passing in the chunks, not just the embeddings, is that when it stores all of the embeddings, it's also keeping track of all the chunks. That way, when you retrieve documents later on that are related to the query, you're not just going to be given the embeddings, which are just numbers, that's not useful. We're also going to be given the actual documents that is represented by the embeddings so that we can provide them to the model to answer our question. So let me show you what I mean by actually doing a query. So we can do query is equal to, and now we can ask a question that we know the Constitution will contain. So how long does the president's term last? Now we can use our vector store to answer that query. So it's going to return a list of documents, relevant documents, and then we can do vector store dot similarity search. We want to pass in our query, and then k is equal to 3. So what this will do is take in your query string, convert it to an embedding, compare it against all the embeddings that the vector store currently stores, and return the top 3 related documents. So as we know, when we learned about embeddings, embeddings encode the semantic meaning of the text, right? So when you call similarity search, it's going to compare the semantic meaning against all the other embeddings to give you the top 3 related embeddings. I really hope that makes sense. So the k is just how many relevant documents we want to return, with the first one obviously being the most relevant one. So this returns a list of documents. So this returns not the embeddings, like I said, but the actual documents that are represented by these embeddings, because this is the data that's actually useful that we can provide to our RAG. So what we'll do is just go through each of the documents that was returned from the search and just print them out, print the contents, and we'll see what we get. So it's kind of a lot to look at, but let's just take a look here. And so the question was, how long does the president's term last? So we should expect this top document here to have relevant information. So it says, no person shall be elected to the office of the president more than twice. And then it just has some more information. And then the next document says, he shall be chosen for the term of 4 years. And then we have the third document, which seems to be less relevant. It's not directly related to the president, but it relates to how the president fills up his cabinet. So what you would do is take these documents, like the first one, maybe even the second one, and provide it to a large language model along with the original query, which is this, and tell the large language model to answer the question. And so the large language model will see in this document that it tells you that his term is 4 years, so it can tell you the answer of 4 years. One thing that I'll show you just real quick is that you can save this vector store to a local file if you want to, so that you don't have to reindex everything or recalculate the embeddings every single time. So you could save it, and then next time you start your program, you could load it. So with all this, we are now finished with our indexing pipeline. So we finished, taking in documents using document loaders, splitting up documents using document splitters, embedding documents using embedding models, and then also storing them into a vector store. And then we went a little bit into retrieval, which is our part of our generation pipeline, which is retrieving relevant documents. In the next episodes, we'll see how to do that in more detail and also how to do the full RAG generation pipeline. So hopefully you're excited. Hopefully you guys found this interesting. So that is it for this video, everybody. Hopefully you guys found this interesting. If you guys are confused on anything, then let me know in the comment section below. I'll see you guys next time. Peace. All right, now that we are getting into the generation pipeline of RAG, it's important that we talk about retrievers real quick, which are an abstraction within Langchain that takes in a query and outputs a list of documents. That's all it is. So basically, it's a thing called retriever, and this implementation here can be anything as long as it takes in a query and outputs a set of documents. And so every retriever is going to be something called a runnable, which basically means that within Langchain you can call invoke, which will just run the code of the retriever. In this case, we take in a query and output a list of documents. This is really good if you want to do some more advanced stuff like chains and stuff like that. We kind of saw this before with chat models where you can have a prompt template and then chain it to a chat model or a large language model and then call invoke on the chain, and it will pass everything through and give you a final result. So we could also sort of integrate a retriever into that. But right now for our use case, we're going to be using retrievers for our generation pipeline, which is Retrieval Augmented Generation. So retrieval means that we're going to fetch relevant documents to augment into our prompt to feed to a large language model to generate an answer, right? So most of the types of retrievers that you're going to be working with are probably going to be vector stores. This is what we saw last time. So we made a vector store like the FAISS vector store from Facebook. We stored a bunch of documents within that, and then we can query that vector store for relevant documents or relevant chunks, right? We can also take a vector store and get it as a retriever. That way we have a common interface to call invoke and stuff like that, right? But besides vector stores, you have other types of retrievers like search API retrievers. So you can search the internet for relevant documents. But just an example of a non-vector store retriever is the Wikipedia search retriever. So this one tells you what to do, of course. We just need to install the Wikipedia package. And then what you can do is instantiate the retriever and then call invoke with a prompt, which is just going to be like a thing that you want to look up on Wikipedia. And this will return the relevant Wikipedia information for that query. So just as an example, if you wanted to make a RAG app that can give you an analysis of a specific topic, what we could do is use our Wikipedia retriever. So we could ask the user first for a topic. We could take the topic, invoke the retriever with that topic. So in this case, Tokyo Ghoul, and then that will return, relevant documents that we could, utilize. So we'll take that document or a part of that document, if it's a big document, and feed it along with the original topic to a large language model and give us an answer. So let's see an example of how we can use the Wikipedia retriever real quick. So we're going to install these packages here, including Wikipedia, as it told us to. And then now we could do Langchain community dot retrievers import Wikipedia retriever. And now we'll instantiate it as the Wikipedia retriever. And then we can do docs is equal to retriever. And now we'll invoke it with a topic. We'll say something like, I don't know, juice world. And so now every retriever, like I said, is a common interface, which is retriever. So every retriever you can invoke, and it should return a list of documents, at least one document. So now we can go and do docs 0, we'll get the first one, and then we'll do page content. We all know Wikipedia documents can be pretty large, so we'll just print out the first 200 characters, okay? Let's try it out. There we go, we get Jared Anthony Higgins, his birthday, known professionally as Juice WRLD, and gives you a bunch of information about him. So something specific about this retriever though, since we're talking about Wikipedia, it doesn't really go with questions very well. So we could say like, who is the current president? Let's try running this to see what we get. So it gave us something that's totally incorrect. And I even saw before that if you invoke it with a question, it will give you a warning and not work. I did see that at some point. The reason for that is because, of course, we're searching Wikipedia and it's not giving us chunks of documents, it's giving us full Wikipedia pages, right? So if with this specific retriever, you just want to give it a topic rather than a query. But for something like a vector store, it's different because we're trying to query a vector store with a question and get relevant documents to hopefully answer that question. And Wikipedia retriever is simply not meant for that. So I'll show you guys now how to use a vector store or vector database as a retriever. So we'll do a lot of the code that we did before. So we're going to bring in our constitution document, load that in using the web-based loader. Then we're going to split it using the recursive text splitter. And then we're going to instantiate an embeddings model. We're going to use a Hugging Face embeddings model called all-mini lm L6 v2. It's just a popular one. Then we're going to create an in-memory vector store, which is provided by Langchain, and load those documents into the vector store by specifying our chunks and the embedding model to embed them with. So that will do all of that. Okay, it's done. So it took a second just because, we have to embed 430 chunks, which is a lot. But now that we have that, we can use our vector store as a retriever. So before I showed you can do vector store dot similarity search, and this is a method available to this vector store, but it's a good practice to convert your vector stores as a retriever by doing as retriever so that you can use that common retriever interface I told you about, and then you can invoke it and also use it in chains and stuff like that, like I mentioned before. Okay, so just convert your vector store to a retriever. So retriever is equal to vector store as retriever, and then now you can invoke it by doing docs is equal to retriever. It's the same thing as we did above because it's a common interface. And we'll say a query this time, how long can senators serve? So this is a question I know will be answerable because that's stored in the Constitution's text. So I'll just print out the relevant documents. That was really fast. So we got no religious test shall ever be required. And then the second document has the actual answer. So the Senate of the United States shall be composed of 2 senators from each state, elected by the people thereof for 6 years. So 6 years is the question. So now what you would do with these documents after you retrieve it from a retriever is you would augment that into a prompt and then feed that prompt into a large language model. We're going to learn how to do that in just a moment here. Now what it did is it gave us a bunch of documents. Let's see how many it gave us. It gave us 4 documents. If you want to limit it to the top document or maybe the top 2, top 3 documents, you can, when you call as retriever, you can also specify search _ KW args and then pass in a map and say K and then 2. So this argument will just be passed to the underlying vector store to tell it to only return the top 2 results. So if we run it now, we only get 2. There we go. Alright, so that's a basic introduction to retrievers. So now you guys know how to get relevant documents using retrievers. In the next episode, we're going to see how we can use those documents to finish the generation pipeline and generate a response from a large language model. Alright guys, now we're going to do a full example of RAG, or Retrieval Augmented Generation. Up to this point, we learned how to do a full indexing pipeline by loading documents, splitting documents, and then indexing documents and storing them to a vector store. And then we also learned how to retrieve documents now. So we're going to complete our generation pipeline now by learning how to augment our prompt with context grabbed from a retriever. and then how to send that full prompt to a large language model to get a final answer. So with this completed RAG workflow, we'll be able to ask any question we want about the US Constitution. We're going to install Langchain, Langchain Community, and Langchain OpenAI. We're going to be using the OpenAI Embeddings model to do our embeddings, and we'll use OpenAI for the chat as well. So we'll use 4.0 as the large language model for this. So let's install all of those. Let's verify that we have the OpenAI API key set. Next, we will load our document, same as before, and then split it into chunks using the recursive character text splitter. Now we will set up our OpenAI embeddings model. So do from Langchain OpenAI import OpenAI embeddings. And so we'll do embeddings is equal to OpenAI embeddings. And we're going to specifically tell it to use the text embedding 3 large. So we're going to use their most powerful embedding model, but you can choose small or a different model if you want to, of course. And then now we could use this embedding model to store our document chunks into a vector store or vector database. We're going to specifically use the in-memory vector store just because it's easy to use, and also we don't really care about storing it persistently. This is a very basic application. So we'll bring it in by doing Langchain community vector stores import in-memory vector store. We will do in-memory vector store dot from documents, pass in the documents, which are our chunks, and then also our embedding models. So we'll do embeddings like that. So now it's going to ingest all those chunks, convert them to embeddings internally, and now we can use that as a retriever. So retriever is equal to store.asRetriever. So now with this retriever, we have a way of getting related documents from the vector store with a query. But before we do that, let's get a large language model set up so that we can actually use one. We're also going to bring in our chat prompt template so that we can build a template for the prompt that we want to feed to our large language model, such as a system message and also a user message. I'll show you that in a second. So first we'll do large language model is equal to chat OpenAI, and now we just want to tell it what model we want to target. So we'll do model is equal to, and we'll do GPT-4o. You can use, whatever one you have access to or want. This is a pretty good and standard model to use for most purposes. And then now that we have that, we can build our prompt template. So we'll do prompt is equal to chat prompt template from messages, and then we'll open this up with a list of messages. So first we'll say you are a helpful assistant that can answer questions about the US Constitution. So it says use the provided context to answer the question. Important in all caps. If you are unsure of the answer, say I don't know and don't make up the answer. This is a very basic prompt here, but whenever you're doing RAG, this is a very common way that you'll see it. So first we're telling it what it should be doing. So you're an assistant that can answer questions about the US Constitution, and then we're telling it how to do it. So use the provided context, which are going to be our related documents that we fetch from our vector store. And then we also specify, very important, if you are unsure of the answer, say I don't know and don't make up the answer. So this is where hallucination comes in. Hallucination is when you ask a model a question and it may not know the answer. Maybe the model is only trained up to a certain point, so it doesn't know about recent events, or it just doesn't know. So sometimes when you ask a question that a large language model does not know, it will give you an answer and say it very confidently as if it does know the answer, but it doesn't actually know the answer. Because a large language model at the end of the day is just predicting the next word in a sequence, so it doesn't exactly know to not say I don't know. It's just a very common problem with large language models. So we want obviously our RAG application to be a reliable source of truth, of information. So if we ask it a question that is not provided in the context, the US Constitution, or maybe we ask an unrelated question that's definitely not in the Constitution, we want it to just say I don't know. And that way it knows it can just say I don't know instead of having to give an answer every single time that may or may not be correct and hallucinate. Okay. After your system message, you're often going to have a user message. So we'll say user, and then we could simply say question colon, and then we'll have a variable here for the question, and then we'll do a new line, so new line character, and then we'll say context on the next line, and then context as the variable. So now whenever you invoke this large language model, you're going to pass in the prompt along with the variables being injected inside of it. So it'll have the system message, so it knows how to respond, but then it also has the question, the original query, along with any additional context that it can use to answer the question, okay? So we learned before that we can chain these together by doing chain is equal to prompt, and then the pipe symbol, and then large language model, or LLM. So now when we invoke our chain, it's going to pass in the stuff to the prompt and then pass the prompt to the large language model. And now here you just want to ask a question about the Constitution. We'll say, what does the Constitution say about pardons? So we'll ask that question. It should be able to give us an answer. So once we have our query, we want to do RAG, right? So Retrieval Augmented Generation. So the first step of that is retrieval. So for that, we'll use our retriever. So docs is equal to retriever dot invoke and then pass in the query. So as we learned before, what this will do is take our query, convert it to an embedding, and then compare it against all the other embeddings stored in our vector store, and then return the related ones. So that's the retrieval part of RAG, of our generation pipeline. The next part of RAG is augmented, and then generation after that. So we're going to combine these two steps together. Augmented plus generation. The reason we're combining it is because all we got to do is do response is equal to chain dot invoke, and then we can just pass in our variables, which will be augmented into the prompt, and then now we're going to pass that prompt to the large language model. That's generation. So that's why it goes together, okay? So we can open this up. We can pass in our question variable. So the question is just going to be our original query. And then after that, we have our context, which are going to be our related documents that we've pulled from our vector store. However, these documents here is just a list of document objects, right? We don't want to pass that into our string here. That doesn't really make a lot of sense. So what we should do is convert each of these documents to just the text content and then pass that final text content into our context variable. So one way you could do this is by doing docs content is equal to, and we'll do new line. This is a little bit of a weird syntax. I'll explain it after. So we'll say join, then doc.page content for doc and docs. So it's weird syntax, but what this will do is loop through each of the documents in our docs list, extract just the page content, which is a string, and then join each of them by double new line, which is just a full line separation. So basically this will be one string with every single doc chunk separated by a new line. So now down here we can pass it in by doing docs content. And that's it. So now we can just go ahead and do response dot content. And that should give us a response from the large language model. Ignore this. So let's run it. So first we got to go back up to the top here. Let's just run everything from scratch. Okay, setting up a retriever. It's indexing everything, so it takes longer. And then this is done. And then finally, boom, here we go. The U.S. Constitution states that the president has the power to grant reprieves and pardons for offenses against the United States, except in cases of impeachment. Pretty awesome, right? And if you wanted to, you could also print the docs, the related docs that it used to answer the question, just so that you can see that it's using related information. We could also change this query here to a question that we know is not answerable from our source document, the U.S. Constitution, and let's see if it says I don't know, or if it hallucinates. So we're going to ask a question like this. Is there any plans to change the U.S. Constitution to allow for term limits on senators? The Constitution says that senators have a term size of 6 years, but it does not, obviously contain any information about future plans to allow term limits on senators. So it should say I don't know. There we go. It says I don't know of any specific current plans or proposals to amend the U.S. Constitution, blah, blah, blah. So it didn't say just I don't know. So it did go beyond what we told it to do. And this is just a function of prompt engineering. So we need to craft a better prompt so that it knows not to go beyond I don't know and just say I don't know and not make up a bunch of stuff. Well, I mean, this is true. It obviously, that makes sense. But we shouldn't have it say all that. That's not something that we want potentially. Maybe you do, maybe you don't. But if you wanted to just say I don't know, you just need a better prompt. If we ask it a more unrelated question, it will say I don't know though. So like, how old is Trump? It should say I don't know. I've tested this. Oh, okay. It did before, so it's a little unreliable, I guess. So there we go. So the unreliableness also shows that it's just a better prompt that it needs. Speaking of a better prompt, Langchain has this hub here where you can see basically prompts that you can use that other people have crafted essentially. This is a very popular one for RAG that a lot of people use. So it gives you a chat prompt template that you can utilize in your project directly. You don't have to worry about making the prompt yourself. So it says you are an assistant for question answering tasks. Use the following pieces of retrieved context to answer the question. If you don't know the answer, just say that you don't know. Use 3 sentences maximum and keep the answer concise. And then question, context. So that's where you pass in the variables. And then now it's saying you should give an answer. So this is just a user message. It's not using a system message. So that's another thing that you could do if you want to. And this is how you can bring it in. So let's try it out. So we'll do from Langchain import hub. And then we're going to replace our prompt here with the hub prompt. So we'll say prompt is equal to hub.pool, and then we want to pull that specific name, which is listed as rlm/rag prompt. And then the variable names are the same, so just question and context, so that we shouldn't have to change anything here. Let's rerun this, and we'll try it out. Okay, it still says I don't know, and it says more. That's interesting. But let's change it back to a previous question like this. It should still work perfectly. There we go. It's a little more concise as well too, in this case at least. So anyways, that's just a prompt template that someone has created that is very popular that you can bring in if you want to. But you could craft your own if you want to, or you can bring in even other ones that people have created that are very reliable as well. Okay, here's a cool piece of code that you can do. If you have an infinite for loop, you can make it so that the user can continually ask questions until they type a specific command like exit. In the next episode, we'll see how to actually make a whole little website for this so it's easier. But this is one way you can make it also easier to work with. So let's run it. So if you're using a Python notebook within VS Code, it'll ask you at the top here. Sometimes you don't, it's hard to notice it, but we could say how many branches are there, something like that, I guess. Let's see what we get. There are 3 branches: legislative, executive, and judicial. Tell me about the Supreme Court. The Supreme Court of the United States is the highest judiciary authority in the country with the judicial power, blah, blah, blah. So as you can see, it just repeatedly asks you for questions so that you can keep testing it over and over until you type exit. And there we go. Now it terminates. So that's it. That's all I want to show you guys for this episode. Now you guys saw a full end-to-end example of RAG, Retrieval Augmented Generation, using Langchain. So we did our indexing pipeline by loading documents, splitting them, and then embedding them and indexing them into a vector store. And then we finished our generation pipeline by setting up a chat model with a chat problem template. And then finally, we use our vector store retriever to get relevant documents and then invoke our chain, which is our large language model on prompt, using our question and relevant documents, and get an answer. So this basic setup here is RAG. With this, you should be able to learn how to do even more advanced stuff, like setting up message history or just making more advanced apps in general. So if you have any questions about anything that I showed you today, if anything is confusing at all, then please let me know. I will see you guys next time. Peace. Okay, guys, I want to do something fun now, which is take what we've learned so far with RAG and make it into a little web app so that we can test it out more easily and it just looks way better. Here's an example of what we're going to be building. So it's going to have a input for a URL. So this is just that same constitution URL that I've had the whole time, but you can change it to whatever you want. And then once you have the URL for the website that you want to ingest and ask questions about, you click this button here. So now it's going to download the website, essentially split it into chunks, and then index that into a vector store for us to ask questions from. There we go. So once it's done, it'll say RAG system initialized successfully. So now in this input here, we can have whatever question we want to ask it. So behind the scenes, it has, of course, our prompt template. So it's going to automatically know to inject the context and all that fun stuff for us. So we just need to ask whatever question we want to ask. So we can say, how long can a senator serve? Let's click get answer. Now it's going to generate the answer. Here we go. It says a senator can serve for 6 years. And then what's really cool is that we can click this drop down here and it tells us exactly the context that the large language model was provided to answer the question. So you see relevant document 1. The formatting is a little weird here, but it says the Senate of the United States shall be composed of 2 senators from each state elected by the people thereof for 6 years. So there's the answer to the question. And then there's more documents after this that are relevant, but it makes sense for this one to be the top one because it has the answer, so it's most semantically related. So the vector store did its job correctly. I don't know about you guys, but I think this is pretty awesome. So keep watching if you want to see how to make this. All right, we're going to start by making a new folder called apps. This will store any apps or little projects that we're working on. We're going to create a new file within that called web_rag. And instead of a Python notebook, we're just going to do a Python file. And then after that, what we want to do is install a package called Streamlit. It's a really nice library for building websites using Python. It's very popular for machine learning and AI applications to quickly get a demo out. And it also has, built-in components and stuff like that. So it's really perfect for what we're trying to do. So we're going to open up a terminal, new terminal. Let's ensure our Python environment is activated. There we go. And now we can do pip install Streamlit like that. So now it should be installed into this environment for us to use. All right, all done. Let's start coding now. So the first thing we want to do is import Streamlit. Import Streamlit as st, as a little alias. And then now we could do some stuff like setting up set page config. We can provide a page title. So this will literally just be the title of the web page. So we'll say rag web demo. And then we could also do a page icon if we want to. Make it snazzy, and we could put a little trick here is if you're on Windows and you do Windows key dot or period, it'll bring up this emoji chooser thingamajiggy here, so you can choose a bunch of different emojis and symbols and stuff like that. So we could do like the robot emoji, for example, and that will be the icon of our website. And one other thing we'll do is set layout to wide. Now we're going to do st.title, which is different from the page title. This is the actual title of the website, but this title here is going to be the title at the top of the website, the web page itself. So we'll say rag question answering demo. Next, we'll do some of the basic stuff that we've done previously. So I'm going to copy and paste this. So we're going to load our Python environment. So for that, we'll import load.environment from .env. I showed you how to do that previously. We'll also import OS. So this will allow us to load our environmental variables from our .env file, as I showed you before. And then if it doesn't exist, it will give you an error and then stop the application from running. Now, like I showed you in the demo, at the very top, we're going to have an input where you can put a URL. This is where we're going to get our data from. So we're going to use a data loader that can extract information from URLs for websites. So let's add our input. We're going to do URL is equal to st for Streamlit text input. Now we can put a label for the input. So enter a URL to load documents from. And then if you want to, you could have a default value within that. So this will be that same exact URL that we've been using the whole time for the constitution. So whenever someone enters a value or uses the default, it will be placed into this variable for us to use. So now we can initialize the button below that so that when you click the button, it actually loads the data, right, and indexes it. So we'll say if st.button, and then we'll give the button some text. So we'll say initialize rag system. You can say load or something like that, whatever you want. So the if is to determine if this is clicked or not. If it is clicked, then we'll do a spinner. So with st.spinner, just to make it look nice, loading and processing documents. And then now while it's loading, we can actually do the stuff that we've been learning about. So first we'll set up a document loader. So loader is equal to web base loader, which we need to bring in from Langchain. So let's do that. Langchain community document loader is web-based loader. And to that, we pass in the URL of the thing that we're trying to load. And now we can actually extract the documents from that. So documents is equal to loader.load. So this is our indexing pipeline. So first we're loading our documents. Now we want to split our documents. For that, we'll use the very popular recursive character text splitter. Recursive character text splitter. So we'll configure a few things. We'll do a chunk size of, let's just say 1000, and then we'll do a chunk overlap of 200. And the separators, you can specify them if you want to, but it'll just use the defaults, which will, as we learned, separate them first by paragraph, and then by sentence, and then by word, and such, okay? So it tries to keep together the units of text as much as possible until it can't, to get it below 1000 characters. So let's split our text now. We'll do chunks is equal to text splitter dot split documents, and then we'll pass in those documents like that. After we chunk our text, now we want to store it in a vector store. So we'll need to choose an embedding model for that. So we'll do embeddings is equal to, and I want to use, you could use whatever you want. We learned there's a bunch of different providers for that, but I want to use the OpenAI embeddings because they're pretty good. They're fast as well to calculate since you're using their, machines, not ours. So we're going to do from Langchain OpenAI dot embeddings import OpenAI embeddings. So now down here we can do OpenAI embeddings. And one of the OpenAI embedding models that we learned about is text embedding 3 small. You could also do larger if you want to. Now for the vector store, I'm just going to use the Langchain in-memory vector store because we don't really care about storing it persistently. At least for this application, we're just going to be loading it from scratch every time you click the button and then storing that. That's not the most efficient thing if you're going to be loading a lot of data, because you have to, pay every time you use the OpenAI embedding model, but I think for this basic example here, it's fine. So do vector store is equal to, and we're going to do in-memory vector store dot from documents. So first we're going to pass in our document chunks, and then after that we want to pass in the embedding model to embed them with, so embeddings, like that. And then also we want to store this in the session state of our Streamlit application, so that's able to grab the vector store to use it to do RAG with. So to do that, we can do st.session state.vector store, and then we'll just do a success message that says it was initialized successfully. Okay. So now that we have all that, that's to actually set up the RAG and everything, the indexing pipeline. So now that we have the indexing pipeline, now we can focus on the generation pipeline, which involves retrieving, augmenting, and generating an answer. So since we stored that vector store in our session state, we could do something like if that session state variable, if it's not null, so if is not none, if it actually exists, then we can go ahead and show the next part of the application, which allows you to input a question and get an answer. We want to conditionally show that because we don't want them to be able to ask a question if it's not actually loaded into our system and ready to be asked a question of, okay? So first things first, we want to set up our large language model. So LLM is equal to chat OpenAI. We can specify which model we want to use. So I'm going to use GPT-4o. Then I'll bring in my chat prompt template. So we have a system message that says you are a helpful assistant that can answer questions about the provided documents. Usually provide a context to answer the question. Important, if you are unsure of the answer, say I don't know and don't make up an answer. So standard RAG prompt right there. And then we're also going to have a user message that actually takes the question and the context to answer the question with. So now with that, we can do chain is equal to prompt and the LLM to bind them together. And now before we continue with this, actually, let's test out to make sure that everything renders successfully because we haven't actually ran it yet. So to run a Streamlit application, go back to your terminal. And then now inside of here, we can run the command streamlit run, and then you can put the name of the file. So we can do, in this case, it's apps and then webrag. And so you could go to this local URL to check it out. It will also automatically open up in your browser. And we can see that there's actually an exception that we need to fix. So the reason that this is happening is because we did not initialize this session state variable before we set it. We need to make sure that it actually exists because it may or may not have got to this point yet, so it can't really access it if it doesn't exist. So all that means is that we need to go back up to the top here, and we could do it here before we add the URL input. And we could say if, and we'll put the name vector store not in st session state. So if that particular variable is not in the session state, then we're going to initialize it. So st.sessionState.vector store is equal to none. So we'll give it a default none value. And so now this will work perfectly. So now make sure you save your file, and then you can come back to the website. And what you could do is click rerun, and this will rerun with the new code changes. Or you can also click always rerun, and it will always reload after you make a code change. So click that. And then now there's no exceptions. That's good. And look at that. So we have our title, we have the URL input, and then we have our button here. So if we click the button, it loads. There's a loading icon, so that's good. And boom, we got our success message. So everything is working so far as we can tell. So now we'll add the input for our question, and then also the other part where it has the answer for the question and the provided context. What I've decided is I want to have two columns. So the left side, the first column will have the question input, and the right side will have the answer, as you saw in the demo. So with column 1, we can have a subheader, so st subheader, and we could say ask a question. Don't you just love Streamlit? I don't know, I mean, if it's coming across, but it's just crazy how easy it is to make this little website just by having, simple function calls like set page config, set title. We can add inputs so easily with default values and labels and handle buttons really easily using Python code. It's really, really cool, right? And it's easy to get started with it. So once we have our subheader, we can add our question input. So question is equal to st text area. A text area is different from an input. An input is just, as you saw, a smaller box that's like one line, but a text area is a bigger text input that's meant for multiple lines of text. So we'll do a text area, and we'll say enter your question as the label. And so once someone puts a question in that text area box, it will be in this variable here for us to use. So we could say, well, let's have another button. We'll say if st button get answer. If that button is clicked on, we'll say if question. We'll make sure that there's actually a question in there if it's not null and everything. If there's a question, we'll have our spinner so we can, show that it's working. So we'll say with st spinner, and we'll say generating answer. There we go. And now this is where we get to our generation pipeline. So first we want to get the relevant documents. So we'll get a retriever using our vector store that we've stored in our session state. So st.sessionState.vector store, and then we could do as retriever. And then now we could use our retriever. So docs is equal to retriever dot invoke question. So we're simply passing in our question, which will be embedded, and it's going to fetch relevant documents to hopefully be able to help answer the question with. So now we can generate a response by doing response is equal to chain dot invoke. We're going to pass in the variable, so question is just going to be question, and then context is going to be our documents, but we want to convert those documents to a string. So for that, I'll do this piece of code here. So it's just going to convert each document to its page content text and then separate it by a double new line so it's separated. And then now we can provide docs content like that. And that's literally it. That's all you got to do to invoke the large language model with the question and the context and hopefully get a correct answer from it. Now just to clean up, what we want to do is take the answer from this and store it in the session state so that we can display it properly. So we'll do session state dot last response is equal to response dot content, and then now we could do st session state dot last context. We're saving the response because we want to show the response of the model, but also we're saving the context because we want to enable them, as you saw in the demo, to see the context that the model was provided to answer the question, because it is pretty helpful to see that. So we'll pass in docs to that. So it will save it. And one other thing we'll do is if the question was null, because we added this here to make sure that they actually provide a question into the text area. If it's null or there's no value for it, we'll just say something like, we'll add a warning and we'll say, please enter a question. So they know, they clicked it without having an actual question to run it with. So that's just column 1. So that's the question part of it. So now we'll have column 2, which is the answer part of it. And then we'll say, well, first we want to check to see if the session state has an actual answer to display. So if last response in the session state, if the session state contains that last response variable that we tried storing in the other column when you click the button, if that actually exists, then we have something to display, obviously. So we'll do st_write. So this will like dynamically show it to the page. So we'll grab the value. So st session state dot last response, because that's the name that we specified here. So I really hope this makes sense. We're just checking to see if the session state has the variable, and if it does, we're going to dynamically grab it and write it to the page so they can see it on the page. So once we have that, now we want to do the part where we show the context, because we're also storing that, right? So for this, we can do, with Streamlit, it's called an expander, but it's just a dropdown, in other words. So st.expander, and we're going to give it a name, show retrieved context. And so when they click that expander, we're going to loop through the contents of each of these documents that we're storing and just display the text for it. So for that, we can do this. I just pasted it because it's easier. So we're simply going to enumerate through each of the documents in the context list and also provide an index number. So starting at 1, and we'll just say relevant document 1 or 2, whatever it's on, and then the actual text, and then separate it with some lines. So if this is confusing, you'll see what it looks like in a second, but basically we're just looping through each document and showing the text for it along with a number. So hopefully that all made sense. I don't think we missed anything. So now, we tested our indexing pipeline. That seems to work. There's no errors at least. And then we added onto that so that if the vector store is actually initialized to something, we're going to set up our large language model in the prompt. We're going to set up our columns. And then when they click the get answer button, it's going to generate an answer, store it into our session state along with the context used to get the answer, and then display it. So there's only one thing left to do, which is test it out. So I'll go back to our website here. And before we told it to always rerun if there was changes, so we already see the changes. So let's ask a question. We'll say, how long can a senator serve? So click get answer. Boom, a U.S. senator is elected for a term of 6 years. There's no limit on the number of terms a senator can serve. So, and then the fun part, the part that I like at least, is show retrieve context. And boom, here we go. So relevant document 1. The second document seems to actually have the answer. So it says elected by the people for 6 years. So that has the answer that ideally the large language model used to give the answer here. Pretty freaking awesome, I must say. I'm just going to experiment with another one. So I'm going to post this link to Google News. And then we're gonna scan it using initialize RAG system. And then let's ask a question like, what are the top headlines right now? Let's see what we get. Here we go. The top headlines based on the provided context are President Trump has signed tariffs on imports from Canada, Mexico, and China. There's ongoing coverage of a helicopter crash. Yeah, this all seems relevant. This is stuff that is displayed here, as you can see. And also at the time of recording, these are the things that occurred. So if you show relevant context, you can see, it's a little messy, but you can see in here a bunch of information about headlines and stuff like that. So yeah, just have fun with it. Put some different websites that you want to try out and then ask it questions, and it should give you answers, hopefully, if you can scan it properly. Some websites are not going to be as compatible using the web-based loader. Let me go back to it. So the document loader we're using is web-based loader, right? Some websites are not going to work as easily. So there's different and more advanced document loaders you can utilize if you want to. So you may have to switch that out. But that's it for this part, everybody. I really hope you guys enjoyed it and found it interesting. If this is your first time using Streamlit, you can see how powerful it is, how easy it is to make these little websites here to test out, what you've been learning, because it's just so easy. I just can't emphasize that enough. It's so easy. So hopefully you guys learned enough about Streamlit to use it in your future projects as well. It's very popular nowadays. So that's all I got. Thanks for watching, everybody. Peace. Alright guys, in the last video I showed you guys how to make a web interface for RAG. So if we just give it a URL, we can initialize a RAG system. So it's going to download the contents of the URL, index it, and then we can ask it a question and get an answer. So we're going to take that and make it like this so that you can also choose a different option to upload a file. So we can upload either a text file or a PDF or what other format you want to enable. And once you upload it, you can initialize it same as before and ask questions about it. If you want to see how to do that, then keep watching. Now, if you've been keeping up with what we've been learning about so far and everything makes sense, this is actually not that difficult. The only main thing that we have to change is our indexing pipeline. The generation pipeline is the same. We're still going to be using a retriever and getting documents and such. But now we're changing our indexing pipeline to load from different sources other than just a URL. If we're going to enable the user to upload files, we'll need to use different document loaders that can handle different file formats. We learned before how to do that with Langchain. It's just different document loader providers. So if it's a PDF file, for example, we can use the PDF, document loader, right? The other aspect will just be using Streamlit to add the new interface changes that I just showed you. So let's get started. So what I'm going to do is copy this into a new file called web-rag extended. So we have it separated. And so now first we want to make it so that they can switch between the regular mode, the URL mode, and then a file upload mode. To do that, we're going to add, before we add our URL input, a selector. So we're going to say input mode is equal to Streamlit radio. A radio is just like a multiple option selector. So we'll give it a label. We'll say select input mode. And then after that, we'll have the two options. We'll say website URL and then file upload. And then we'll make it horizontal. Now, because we had those two options, we need to make it so that we can switch between different code depending on what they select. So we'll say if input mode is equal to the first one, which is website URL. If they selected website URL, then we want to do all this code here, which has the URL and the button, all that stuff. So we'll take this and just simply indent it into this branch here inside the if statement. We'll do the same thing with our button, so it's indented now. One thing that we'll do is move this part out of it. This is because once you have a document, in terms of splitting the document to chunks and embedding it and storing it into a vector store, all that's going to be the same, right? So this can be shared between our different implementations. The part that's different is the document loaders, right? So we'll take this out and we'll just, for now, move it back down here. And now we want to take these documents and store them into a variable of sorts. So we'll just make a documents list here at the top, like that. And then now, once you load your documents, we can then do documents.extend and just pass in our documents. So that's for the website URL mode. We'll have the other mode. So for that, we'll just say else, or you could have else if you have more than just two. So we'll put some code inside of here, but then after that, in terms of actually, splitting the documents and such, what we're going to do is have an if statement. So if documents, so we can do this now, indent it, and now it'll only process it if this documents list from up here has documents from either mode for website URL or the file upload mode, okay? I'll give you guys a recap in a minute if it's a little confusing. So if they're in the file upload mode, we want to show a file uploader. Streamlit has a component for that. So we'll say uploaded file is equal to Streamlit file uploader. And to this, we can give a label name. So upload a file. And then we can specify actually the type of files that we want to allow, which is perfect because different types, if we just allow any type, then that's not going to work because we may not have a document loader set up for that specific type. So we want to give an explicit list of document types. So just for this example, for this video, I'll do text files and PDF files, but you can add as many as you want, right? Next, we'll also add a button. So if Streamlit button initialize rag system from file. So if they click the button, this will run, and then we'll also start doing a spinner. So we'll say with a spinner, loading and processing documents from file. So this will just show the spinning icon while it's processing. And now we'll just validate. So if uploaded file is not none, so they click the button and actually has something. First things first, we want to figure out the extension of the file that they uploaded. So it's either TXT or PDF. So we can extract that just from the file name. So uploaded file dot name dot split, and we're going to split on the dot, and then we're going to get the very last index. So what this is doing is, if you have a file name such as booty.txt, if you split based on the dot, you have two elements, this one and this one. So we're simply grabbing the last one, which is the file extension. That's all that's doing. So if the file type is txt, then we'll use a specific document loader for txt files. Otherwise, if the file type is PDF, then we'll use that document loader for PDF. Now for a text file, it's actually pretty easy. So we could do, for example, raw text. Let's just extract the raw text from the uploaded file. So uploaded file dot read. This is going to be just raw data returned from this. So we can decode it as actual characters. So UTF-8 will give it to us as actual characters, like, keyboard characters, A, B, C, D, 1, 2, 3, and other symbols and stuff like that. So once we have the raw text, we can then, we need to convert it to a document, right? Because we have this documents list. So we'll just do documents.append, and then we could say, we can create a new document, and we could do page content is equal to raw text. We just need to make sure that we import document from Langchain. Now for the PDF part, it's a little different. It's a little more complicated because we already know that there's a Langchain document loader for PDF files so that we can extract documents from a PDF. The thing that complicates it a little bit is just because we're uploading it to our website using this Streamlit file uploader, and that will basically load it into your computer's memory. It's not a physical file on your computer. So when we use the PDF document loader from Langchain, it doesn't really know how to, it just doesn't work with that, things that are loaded into memory exactly. So one way you can get around this is first save the file to a temporary file, process it into a document, and then delete that temporary file. That's just one way you can get around it, okay? So to do that, you can do this piece of code here. Just make sure that you import temp file like that. So this piece of code here will create that temporary file using the name that we uploaded it with. And then now that we have that, we can take a look at our Langchain document loaders that we have access to. So for PDFs, we have a lot of different ones. One popular one is PyPDF. So this tells you how to use it. So let's use that one in our code. Loader is equal to PyPDF loader, pass in the temp file path so it knows where to get it from. And then now we can do documents.extend, and we can add the loaded documents. So we're loading the documents and adding them to our documents list. And now we're wrapping it within a try and a finally, just to make sure that we clean up the temporary file that we created. So we can do that by doing os.unlink, and then we could do temp path. So all this is doing is once this code has finished running, or even if it errors out, the finally will make sure that it always unlinks the temporary file, and that will delete it, okay? And that's it. So that's how you can process a text file or a PDF file using different types of document loaders. Now the documents, no matter which mode you're in or which file type you upload, will be in this documents list, which we can then process the same exact way that we did previously. So one little quick thing I would add is if this else here for uploaded file, if it is null, then we'll just add like a little warning. We'll say st error. We can say please upload a file, and then we could do st stop. There we go. Okay, so just as a little recap here, we're adding this new input mode, radio. So you have two different options, website URL or file upload. So for the website URL mode, we have a text input. If they click the initialize button, it's going to download the content of that website, create a document out of it, and then put it into the documents list. If we're in the file upload mode, we're going to add a file uploader component to the screen. So if they upload any files to that, which is a text file or a PDF file, we're going to take it, figure out what type of file it is. If it's a text file, we'll just take the raw text, create a document out of that. Or if it's a PDF, we're going to create a temporary file, get a document out of that. And then finally, once that is all done, when we have documents, we're going to split the documents into chunks, use our embedding model and our vector store to store them into memory as embeddings. Then finally, once we have our vector store initialized in our session state, we can use that with a large language model, GPT-4o, with our prompt template, create a chain out of it, and then you can ask a question. So there's a text area for that, so you can ask a question. When you click the button, it will use the chain, so invoke the prompt in the large language model to get an answer using the context with the relevant documents. So all that is the same as before, okay? So I really hope that makes sense. Let's actually try it out now. So to run this, you can do new terminal, and now we're going to cd into apps, and we'll do streamlit run web rag extended, and let's take a look. Here we go, rag question answering demo. So this part still works, that's good. Here's the file uploader, so we can select only TXT and PDF files, that's good. So I've got a PDF here of just a book, Understanding Deep Learning. So I'm gonna select that and click initialize rag system from file. You can see now that it's processing it, that's good. Okay, it's done. It took a while just because it's a big PDF, but rag system initialized successfully, so we can ask a question now. I'm going to ask a question that I know to be in that PDF, like who is the author, and also when it was published. It's on the very first page, so let's try this out. We're going to say, who is the author? Get answer. The author of the book Understanding Deep Learning is Simon J.D. Prince. So looks good. So if we click show retrieve context, we should see that. Here we go. Relevant document 3, Understanding Deep Learning, Simon J.D. Prince. So this has the information. I'll ask another question about generative adversarial networks. Let's try this out. So I'll say, what does the book say about generative adversarial networks, and what chapter is that? Let's try that. This book discusses generative adversarial networks in chapter 15, which is correct. So this is the relevant document that, describes that. So as you can see, it's working perfectly. I don't know about you guys, but I think this is really, really cool. This is yet another example of how you can use RAG to make a pretty cool app. I'm pretty impressed with this. And so you can only imagine the cool kinds of apps that you can create using Streamlit because it's so easy to get started along with the knowledge that you've learned in the series. So try uploading some different PDF files or different file formats yourself and see what kind of cool things you can, do with it. Ask some questions, some tough questions, and see if you can answer it. So that's all I got. Thanks for watching, everybody. Peace. Hey guys, I just want to say thank you for watching my series on Retrieval Augmented Generation with Langchain. I really hope that you learned a lot, and if you have any questions about anything that I told you, then make sure to, leave a comment in the comment section below, and also check the code in the GitHub repository in the description below as well. Now you should be able to take what you learned about RAG and apply it to all kinds of different projects. Anything that involves giving a knowledge base to a large language model. There's a lot more you can learn with Langchain. They have a lot of other features besides just RAG, so be sure to check that out if you're hungry to learn more. But also I just want to say thank you to all of my subscribers on this channel. I really appreciate all of your support, even when I don't post videos all the time. A lot of the time I'm, researching new topics and working really hard to produce videos like this. So I appreciate all of your patience and all of your support over the years, especially to my members as well. Thank you if you're a member or have been a member in the past. I really appreciate your support as well. Thanks for watching, everybody. I'll see you guys next time. Peace.